Hey guys, welcome to my Python for Beginners course. This Python course is meant to teach all new Python developers the bare basics of Python development, all the way from variable declaration and input and output to the very complex stuff such as object-oriented programming, reading and writing files, and much more. This Python course includes 3 solutions at the very end of the course after we have learned all the basics to the language. If you feel that I have left something crucial out of this course, be sure to let me know in the comments, and I do apologize if the quality of this course may not be as expected. This is my first time uploading this type of video. So if you have any suggestions on how I can improve future videos like this one, be sure to let me know in the comments as well. And as always, thank you for watching, subscribe, and I hope you enjoy the full beginner level course on the Python programming language. Alright guys, so before we start programming in Python, there are a couple things we need to address. Mainly, we just need to install the Python programming language to our computer, and we need to install an IDE or a code text editor onto our computer so that way we can actually start coding in our projects. Now, what is an IDE, you may ask? An IDE stands for an Integrated Developer Environment. And basically what those do is it allows us to run and execute and debug our code for our projects. So we're going to be installing both of those, and we're also going to install some tools and extensions for us to help accelerate our Python development. So we're going to go to our browser, and the first thing we're going to do is we're going to go to python.org, and we are going to navigate down to the download section right here, and you're going to download the latest version. I already have it installed, or well, downloaded here, so we can go ahead and double click. And basically you're going to see a screen that looks similar to this, but not exactly. And for you, it's just going to say install. And for me, it says modify because I already have it, but you're going to click the install button, and it's going to bring you to a menu that looks like this. Now, we want to make sure we have these 4 checkmarked, and the reason why is they install the supplement tools that we need for our Python development. We need our documentation because those contain basically tools to help us learn Python and to help us further our development with our projects. We need to install pip, which allows us to install third-party packages written in Python. So if you've been watching my channel for a while, you may now be thinking of stuff like discord.py or numpy or custom to Kinter, a whole bunch of stuff that is important to our projects. So we need to make sure we have documentation and pip installed. Now, this is completely optional, but you can install TCL and TK as well as idle. And basically what that does is it installs the tools and library needed for making GUIs or user interfaces with Python. And there's also Python Test Suite, which just installs the standard library test suite, which we may need at some point whenever we are developing our projects. Now, you don't have to install PyLauncher, but it's usually recommended by most developers. I don't really use it. All it does is just make it easier to start Python. But as long as you have these 4 checkmarked, you are basically good to go, and you can click next. And then all you need to do is make sure you have add Python to environment variables checkmarked. And then if you want to create a shortcut, you can as well. After that, you can just run the installation, which I've already done off camera. So I'm going to go ahead and exit out of this. Excuse me. Now, you're going to need a IDE or a code or text editor. Now, there's a lot of them you can pick from. There is Sublime, there is Atom, there is Visual Studio's Code, There is Notepad++. There's hundreds of text editors that you can get online. I personally like using Code or Visual Studio's Code, otherwise just known as Code. And the reason why is because I can get extensions on there that help me with my Python projects. So that's what we're going to be using in this course, and we are going to go to code.visualstudio.com, and you're just going to click on download for Windows, or if you're on Mac or Linux, you're going to click other platforms here. I already downloaded it and installed it, and I'm not going to really run through the installation process because it's pretty self-explanatory. It's pretty straightforward. All you have to do is just agree to the terms and then install it to a certain location, and also add a link to your desktop if you would like. So I'm just going to skip that part because it's nothing complex like Python's installation. But after you install it, now what you need to do is restart your computer. Now you don't always have to do this, but when you install a programming language or any programming environment, whether it be Python or Java or Node, anything, you need to restart your computer just to ensure that everything is installed and loaded correctly. And after you do that, you can go ahead and open up Visual Studio's Code or your IDE or text editor of choice. If you went the safer route and used Visual Studio Code like I am, once you open it, you're going to see a screen that looks something like this. Now, you may notice I have some extra things. That's because I have a lot of extensions. You may not see some of the things I have, but I promise you have the exact same version as I have. Now, what we can do is go to the extensions, and you're going to navigate to the left-hand menu here. And on the fourth or fifth one down is the extensions. You're going to click it, or you could also just click in Control, Shift, and X on your keyboard. It'll also take you there as well. And we're going to install 5 extensions. Install or install, whatever. We're going to install 5 extensions. First one's going to be the Python support. Now, basically, this is just language support and then IntelliSense. It also installs Pylance, I believe, and the Python debugger. Now, if it didn't install Pylance, then the next thing we're going to install is Pylance. Which, if Python installing this didn't also install Pylance, then you can install it here just by searching it up. But I believe if you install Python, it installs that as well. The next one we're going to install is docstring. Now, this is optional, but basically, if you plan to make a library in Python, then you're going to want to have this because it auto-generates doc strings for your classes and functions and methods and stuff like that. And you also might want to install Tab9. Now, this is absolutely optional, but I like Tab9 because it acts as a autocomplete whenever you're programming. So, whenever you're typing out your code, the AI can predict what you are going to type out, and then just allow you to hit tab and finish out what it thinks you're planning to type. So it just acts as a autocomplete tool for your code. Helps you code just a little bit faster. Now, there is a paid and free version. I believe the paid version is just a little bit better. It's a little bit more updated and a little more powerful, but the free version works pretty well as well. Last one is going to be CodeRunner. Now, CodeRunner isn't just for Python. It's for just about every other programming language, but it basically just allows us to quickly run at the click of our button inside of our IDE here. But if you don't like to use this tool, there's also another way to run our Python scripts, and that's just through the command prompt. But after that, you are basically good to go. We can now create our very first Python file. So what we're going to do is we're going to click on Open Folder here, and we're going to go to wherever we want to store our projects folder. I have mine stored under programming, and I actually made a project folder specifically for this course, so I'm going to go ahead and add that. And to create our Python file, all we have to do is just right-click, click on New File, and then we can name our file. And I'm going to name this main, because that's usually what we name most of our main Python files. And then we're going to end it with .py, because py or py is the file extension for a Python script. Hit enter, and your Python file is now created, and you can begin typing your code. Now, whenever we want to run our script, which I'm just going to show you guys, I'm just going to type in a small little bitty script. And if I go ahead and run it, all I have to do is just type or hit these 3 dots up here, click run or debug, and then run code, or you can just hit Control Alt and N on your keyboard. And as you can see, it works just like that. Another way you can run your code is you can go to where your project is housed. So if I navigate to where it is at, disk, programming, you go to where your Python file is housed, and you click up here and just type in cmd. You can open that project folder in a command prompt, and all you have to do is just type in Python and then the name of your file. And it works just like that. So that is all we had to do to set up our Python file, and now we can begin our coding. Alright guys, now for this first segment of actual coding, we need to talk about some of the most important things in Python scripting, and that is the print and input functions, as well as commenting lines and variable declaration and assignment. So what does the print function do? Well, judging by the name, it might make you think of a printer or just printing a piece of paper if you've never really programmed before. But actually, contrary to that, the print function really just displays a message into the output terminal or console, depending on what you call it. And if you're not sure about what I mean, I'm talking about the little box that comes up at the bottom of Visual Studio's code when you click run, so such as this here, or if you prefer to run it through the command prompt, it would be this right here after you type in the command to run your file. So that is what I mean by terminal or console or output, whatever you really want to call it. They're honestly all the same, in my opinion at least. That is what I mean. Now, how do we put in a message here? Well, in between these two parentheses, we pass in a variable name or a value, which is known as a parameter or argument in scripting. So if I wanted to type in a message using these double quotes or single quotes here, we could type in something like hello world. Now, what this value is known as in scripting is a string value. And we make a string by using single or double quotes and then typing in the value content in between them. Now, we'll get more into strings and also other value types in the data types section of this course. But that is what this message is known as. It's known as a string, and the value is hello, comma, world, exclamation point. Now, if I go ahead and run this, let me just navigate back to my tutorial here. And for these single line scripts, I'm going to use this command prompt right here to run my script. But if I go ahead and just type in Python main.py, which is the file name, as you can see, we get the message hello world. So why might you use this print function? Well, it's really useful for debugging or logging any occurrences, whether it be errors or just any like notes, just to help keep track of what's going on when your code is being executed. If you have a problem occurring in your code, but you're not sure what exactly is causing it, but you have an idea where it might be happening, you could use these print statements to help figure out what line is exactly causing the issue in your code. So if you have a code and you're running into a problem where this bot you're making can't connect to your web page project through like a sign-in form or whatever, you can put in print statements like connection successful, connection failed, sign-in successful, sign-in failed. Things like that can really help you determine where a bug or a fault might be occurring in your code. Now, there's another function that works similar to print, and it's called the input function. Now, you also pass in a message in here, and for an example, I can type in, "What is your name?" And I usually add a space afterwards, because if you don't, then when you type in, it's going to be like John or something, rather than John. So I usually leave a space after those, after the end of the message. And basically what that does is, if I navigate back to my code once again, and I should probably stop closing this, but what's going to happen is whenever I run this script, it's going to say, "What is your name?" And then it's going to keep waiting until you pass in input. So if I type in John Doe, for an example, it's not going to do anything until I press enter. Now, if I have any code to be executed after that, it'll of course execute that code and then finish the program. But what this does is it's going to print this message out into the console. It's going to wait for an input. And if we have this in a variable, it's going to store the input that we just put in. So I put in John Doe. So it's going to store a string of John Doe inside of a variable, and then we could use it later. So after I get into variable declaration, which we're going to do now, I'll show you how we could set something up like a program that asks for your name. So what we can do is we can go ahead and start creating variables for those inputs. But first, we need to know how to create a variable. And it's very simple. We just create a variable name like X, for an example, and we set it equal to the value. Now this could be a message like "Hello World." And if I decide to type in print, instead of having to type in those quotations and "Hello World," I can just pass in X. Now, if you have a very good IDE, you may notice that it can go ahead and do an autofill if you have that type, or I can't remember the name, the Tab9 extension. If you have that extension installed, it might go ahead and autofill like it is now, or you can just click that and it will go ahead and pass it through. Now, whenever we run this script, even though I don't have "Hello World" typed in between those parentheses, I have X, and when I pass in X, it's going to reference to this variable declaration here, and it's going to pull that value from X. So if I go ahead, go back to the console, and type in Python main.py, it's still going to say "Hello World" because we passed in X, and what it did was it pulled the value from X. Now what if I also have X again and I set it equal to something like 11? Well, now if we go ahead and type in Python main.py, what it's going to do is it's going to print out 11 instead of "Hello World." But why? X is clearly equal to "Hello World" up here on line 2. Well, the thing about executing code is it's always going to be executed from top to bottom. So this line 2 is going to be executed before line 3. And whenever it comes to variable declaration, the last value to be assigned to that variable is going to be the value of that variable. So because we defined X to be equal to "Hello World" up here, we later redefined it to be 11. And because that was the last value we defined X to be, 11 will remain that value for x. Now, of course, if I just move that up there, now I have x is equal to 11 first and then hello world second. Now if I go ahead and type in Python main.py, we're going to get hello world. So if you ever need dynamic variables or variables that change value quite often, be sure to know where you're defining your variable to be this or that value. Otherwise, it can cause some issues with your code, it can cause some conflicts, and we don't want that as well. It causes everybody problems. Now let's talk about commenting code. So let's say I have print hello world 1, and I'm going to print this 3 more times. And change this to 3, and then this one to 2. And obviously, if I go ahead and just run this script, I'm actually going to go ahead and copy that. As you can see, it prints out hello world 1, 2, and then 3 times. And nothing's changed. So, how do I comment out a code? Well, if you've programmed in other languages, you may know it's a double slash. In most C-based languages, Java, JavaScript, PHP, you use a double slash to comment out code. But in Python, it's actually done with a hashtag. But what do comments do in code? Well, they are lines that are ignored in Python. So whenever you have a comment in your code, it will not be executed. So what if I go ahead and comment this line 3 out using that hashtag? Well, if we go ahead and run the command prompt here and run our script, we're only going to get hello world 1 and hello world 3 because this line here, line 3, is being ignored despite that we have a print function in it. Now, what might this comment feature be useful for? Well, if you have other people reading your code, then what you're going to want to do is you're going to want to include some comments to help give some context to your code, so that way people reading it can know exactly what's supposed to happen here. What's exactly supposed to happen on this line? What does this line do? What does this function do? You know, you want people to know what your code does, and you don't want to have them left with their head scratching, trying to figure out what your script is for. So a good way to do this, after your line is done, after you're about to go to a new line, you can include a comment on that line and then just say, prints out hello world to the console. So for whatever reason, if anyone doesn't know what this print function here on line 3 does, well, there you go. There's a message that describes what it does. And of course, if I go ahead and run this code again, we just get the same thing that we would get if we didn't have this comment. And it works pretty simple. You don't see it on the output side of things, but when you actually read the code, you will see it. And it's very useful if you're working as a programmer with a team of people, a team of developers. Your coworkers will be able to read your code, point out anything they need to point out, and in general, they will know what your script is supposed to do. And it's a good idea to have a lot of comments in your code, especially if your code becomes pretty complex. But with that out of the way, let's go ahead and set up a pretty simple exercise here. So I want a program that works in the console and asks me for my name and age. Well, what I can do is I can print out, welcome to greeting application. Please answer the questions for or to be greeted. And I'm actually going to go to my settings here and change this to about 24. There we go. And then I can create a variable and call it name, and then set it equal to the input. Yes, you can set variables equal to functions if they return a value, which input does indeed return a value. So you can type in name equal to input. Please enter your name. And we could leave a colon there with a space. And then we could type in print, or I'm sorry, we could type in age. We could set it equal to input. Oops. Great. What is your age? And then, lastly, we can finally print out greetings. Sorry, I'm trying to figure out what's a good message. Greetings. And then name. And then what is it like to be years old? Now, before we run this program, take a look at what I've done here, because it may look a bit complex, but we can actually insert multiple values inside a print function using this comma. So if I want to print out name and age, I can just type in name, comma, age. But there's also another thing we can do. We can do something called concatenation, which is done with a plus sign. And basically it merges all of these strings together. And actually I don't need this space here because I'm not concatenating. But we could also do another thing, which is honestly my favorite, and it's called an f-string, which is available after a certain Python version, but it's been around for a long time. And in this f-string, we can actually insert our values into certain places. So we can type in greetings. And then to insert a value, we would type in a set of curly braces, and inside those curly braces would be the name of our variable. And then we could type in, what is it like to be years old? And that's it. So there's 3 ways we can have values with our strings in a print statement. We could use concatenation, which is like string 1 plus string 2. So if I have string 1, it's equal to hello, and then string 2 is equal to world, then basically what string 1 plus string 2 would be hello world. Now the thing with concatenating strings is that there's no space included. We have to include that space ourselves by either adding a space after the first string, so we could add a space right here, or we could add a space right here. And either way, there's going to be a space included. Now, if we're ever using a string length function or a length function, what can happen is that space could be counted as an extra character. And that extra character, I believe, will take up extra memory in storage. Now, while, of course, I mean, with a simple string like that, you're not even taking up a full byte of data. Or at least I don't think you are. But, you know, if you're making like a video game with Python, that might be something important for you to know. Now, of course, concatenating and then just using a comma to separate strings and values in a print statement, and also using an f-string, all really depends on your preference. I like f-strings because I think they're the easiest. It's just one string where we're inserting values at different places using these curly braces and then just putting in the value like that. So let's go ahead and run this application. Python main.py. Welcome to greeting application. Please answer the questions to be greeted. What is your name? All right, I'll go ahead and put my name, Tamer. And now it says, great, what is your age? And I'll put in 19. And now it says, greetings, Tamer. What is it like to be 19 years old? So, pretty nice. We have two input variables, name and age, which send out the message and then wait for user input. And then it stores them in those values as strings, and then we can go ahead and print them out to the console using that neat little F string I just shown you, or we can concatenate those strings or use commas to separate them in the print statement. So pretty nice. We just made our very first simple input and output application in Python. How very nice. So if you managed to do this without any trouble, good job. You just made your own first little mini Python project. And the rest of this course gets progressively a bit more difficult, but I promise this is a very easy-going Python course, and it is designed for beginners if that fits your level of proficiency in the Python language. But without further ado, let's go ahead and head to the next section. Alright guys, let's talk about mathematical operators in Python. Now, what are mathematical operators? Well, they are operators that allow us to perform mathematical operations in Python, so we could use them to build equations to later evaluate inside of our script. Now, there are 7 mathematical operators, one being the addition operator, which is denoted by this plus sign symbol. And I'll just go ahead and put addition here. Then we have subtraction, denoted by the minus sign symbol. And then we have multiplication, which is denoted by the asterisk. Then we have divide, which is denoted by a single slash. Now, that's the 4 common ones you'll probably use most of the time, but there are 3 more mathematical operators. There's a percent symbol, which divides and then finds remainder. This is called the modulus or modulo. And then there's a double slash, which is floor division. And essentially what floor division does is it works the same way as the percent or regular slash operator, but the double slash operator will divide x by y, but it will round the answer down to the nearest whole number. So for an example, if we have 10 divided by 6, I believe that equates to about 1.6 repeating. Now, basically, even though 2 is closest to 1.6, so if we wanted to round it to the nearest whole number, we would actually round up to 2. Floor division ignores that entire rule and just rounds down to 1, which is why it's called floor division. Now, the opposite of this would be ceil division or ceiling division. And essentially, we don't really have an operator for that in Python. But if we wanted to, we could use the round function, or we could also, later on when we get into importing modules and libraries, we would use a special function from the math library called ceil, and we could round up to the nearest whole number instead of down. But that is what the double slash does. It divides just like the single slash operator, but rounds down to the nearest whole number. And then we have one last one, which is a double asterisk, which basically means exponentiation. So, x to the power of y. And, or whoops. Here we go. So basically, we could type in something like 4 to the power of 5, or 4 to the power of 2, which is 16, using the double slash operator, or double asterisk operator, sorry. So let's go ahead and do a small exercise here, just using a simple addition, subtraction, multiplication, and division. So let's say we have x and we have it equal to 10, and y equal to 6. Now, I want to add x and y together. Well, we could just type in 10 plus 6. But I want to do something with that value later, so we should create a new variable called z and set it equal to 10 plus 6. But what if x and y are changing in our script? Well, we can simply just replace 10 and 6 in our z assignment to z is equal to x plus y. And if I want to go ahead and print z, and come in here and run our script, and as you can see, we now get 16 in our output. And if I wanted to change that to x, we would just get 10, since it'll only be printing out the value of x up here. Now, let's say I wanted to multiply x by y. Well, 10 times 6, that's going to be 60, and we could prove that by first fixing this where it would actually print z, and then running our script. And we get 60. Now let's go ahead and divide. As you can see, 10 divided by 6, we get a decimal number, which is actually known as a floating point number, or just float in Python. So in this second part, or actually technically part 3 of this course, we have just discovered a new data type called a float. And a float is essentially a decimal number, positive or negative. It's different than an integer because integers are strictly whole numbers, positive or negative. So whenever we divide in Python, it automatically converts our answer into a floating point number, even if it divides evenly. So if I were to change y to 5, we're going to get 2.0, which is still a floating point number, just because Python is set up to automatically convert to floats, even whenever it divides evenly. All right. Now let's try the double slash operator, which is the floor division operator. Now remember, I said that it rounds down to the nearest whole number. So even though 2 is the nearest whole number, it will not round to 2. Our output will not be 2 because that would be rounding up. We need to round down. So our expected output should be 1 whenever we run this script, and it indeed is. Now let's try the percent symbol. And essentially, what the percent symbol does is it finds the remainder. So it divides x by y and gets the remainder. And if I go ahead and run this script, our remainder or our output is 4 because 6 fits into 10 one time, and then we have 4 left over, which is our remainder. Now, lastly, we have exponentiation. X to the power of y, which is inherently 10 to the power of 6. So I'm going to put 10 to the power of 6 up here, which is going to be 1 million. So 10 to the power of 6 will be 1 million. If I go ahead and run this script, as you can see, we get 1 million in our output. If only we had that much money in our lives. But these operators are pretty easy to use. Now, here is one problem with Python and computers in general, and it's not really a problem or a design flaw. It's just something that we need to understand about computers as we're programming. And it's that computers are not really as smart as human beings. Computers are not as smart as the human brain. And I'm saying that because we're going to get into the order of operations here, or what you may have heard in school as PEMDAS, or parentheses, exponents, multiplication, division, addition, and subtraction. Now, Python and any programming language as well as computers do not really understand order of operations well. And whenever we are making some complex equations, we need to watch out for that because our answer could be completely wrong or completely different than what we are expecting. So if I wanted to type in z is equal to 3, and then a is equal to 6, and then b is equal to 8. Actually, let's change a to 5, because we already have a 6. And I wanted to create a new variable called c. And let's say I want c to be equal to 10 plus 6 divided by 2 to the power of b. I'm sorry, let me actually change these to the variables. I don't know what I'm doing here. Let's see, what do I want to use here? Let's use a, whatever. X, Y, A, and B, and then divide that by 3. Or actually z. Dang it, I keep using a number rather than the actual variable. So I could go ahead and run this. And let me just navigate back to my Python file. And of course, I keep forgetting to print C. Sorry, guys. All right. There we go. We get 10.005, almost 10, basically. Basically 10, if anything. But that may not be our expected answer. So what we should do is we could actually wrap some of these pieces of our equation into parentheses. And that basically tells our script to basically do what's inside these parentheses first and then do what's on the outside later. Basically order of operations. Now, we can go ahead and run this script again. And you see that we get a completely different answer. This is completely different. This is nowhere near what we got the first time without these parentheses. So that shows how important it is to remember that computers do not understand order operations as well as we do. So whenever we are making our complex equations in our Python script, or let alone any programming language that is, we need to be careful on where we place certain operators, and we need to wrap some pieces of our equations in parentheses to explicitly tell our interpreter, hey, I want x and y added first, and then divided by a, and then brought to the power of b, and then at the end, divide all of that together by z. So it's always important to remember that, because if you are making something that takes a lot of math, like a video game for an example, you really want your math to be correct and precise, and if we don't watch out for this, that will never happen, and we're going to run into a lot of problems and bugs, and then we're going to be scratching our heads, wondering why it's not working, when in reality, it's just a common misconception that, oh, computers don't lie, computers are smart. They're not smarter than us. We are way smarter than computers. And so we need to really be explicit in how we are defining our equations here. But that's really it for mathematical operators. Now, there are actually plenty more operators in Python, but we will not get into those until later when we start talking about conditional statements. But that is it for this segment, and I will see you guys on the next one. Alright guys, now let's talk about naming convention in Python. Now, what is naming convention? Well, naming convention is a set of rules and regulations that the way we name things, depending on the programming language, essentially is set. So, depending on the programming language you are using or scripting in, you may have a different set of rules and regulations for how you name things like your variables, your functions, objects, even down to the file itself for that script. Now, there are several naming conventions out there, and just to list a few of them, we have snake case, screaming snake case, we have camel case, Pascal case, and more. And those really vary from script to script, or scripting language to scripting language. For an example, JavaScript uses something called camel case, which I'll show you guys in just a minute, whereas Python uses snake case and screaming snake case. Now, when we were defining our variables earlier, you may remember they were pretty simple. There was just x, y, and z, and etc. But what if someone else is reading our code and they don't really know what x and y and z really mean? They don't really know what those values are supposed to represent. What if it's somebody's age? What if it's someone's yearly salary or hourly pay rate? What if it's somebody's trying to think. What if it's somebody's height or weight? What if it's someone's social security number? What if it's somebody's phone number? What if it's somebody's address, maybe? These numbers can represent a lot of things, but we may not know, or whoever is reading our code may not know what that number really is if it's just represented as Z in our script. So we should really be descriptive when naming our variables. So for an example, if I have a name John, yeah, we can name it as something like X and set it equal to John. And if I go ahead and print X, and I'm going to do this in Visual Studios, we get John in the output, and it works just fine. But if this variable was set equal to something more complex that you may not understand immediately, then we're not going to know what X is being used for. We're not going to know why we're doing what we're doing with X in a context of a more complex script. So what would be ideal is maybe naming it name. And that way, whoever's reading our comment, we now know that, okay, this is a name, this is somebody's name. And if we had a last name, like Doe, for an example, for John Doe, we don't really want to just call it name too. Let's be descriptive. Let's be a little bit more professional. Let's call this first name, and then call this one last name. Now, this does not change how your script runs at all. It simply just makes your variables in your code a lot more readable, and this is very useful for if you're working in a team of other developers and you're constantly viewing each other's code. You want to make sure your names of your variables and functions and classes, objects, and even files all follow the same naming convention and are all consistent and very descriptive and easy to read. So that way you don't have to decipher the value to figure out what that variable's for. Now, let's talk about the different naming conventions. What if I have a variable that's supposed to be called first name? Well, you can just set it equal to this, but there are several ways we can name it in several naming conventions. One is called snake case, which is the one Python uses, which is what I just used in that example. And snake case is used by inserting a underscore between every space in your variable. So if you have a variable that's made up of multiple words, you would insert a underscore in between each of those words at every space, essentially piecing them together to be like a snake of words, which is why it's called snake case. Now there's another one that Python uses, and it's called screaming snake case, and it's just all caps but following the same rules for the spaces or in between each words. And this is actually used for defining constants, which are actually a different color than our regular variables. And basically what a constant is in Python, it's a variable that never changes. So think of Euler's number, 2.8172, I believe is what it is, or pi, which is 3.14, and then going on forever. That's what we would use constants for in Python, and we use the screaming snake case naming convention for those. Now, there is another naming convention called Pascal case, which is used, I believe, in C# and also Java, but also in other programming languages as well. And it's usually done like this. So there's no space, no underscore, nothing, but the first letter of each word is always capitalized. And there's another one called camel case, which is used by JavaScript and also PHP, if I'm not mistaken. And it is similar to Pascal case, but the first word's first letter is lowercase, while the second, third, fourth, and so on words have their first letter capitalized. So first name of John, for an example. Our first letter in the word first is lowercase, but we have N and O and J for name of John, all capitalized. That is known as camel case. Now, does it really matter what naming convention you use in Python scripting or any programming language in general? No, it honestly does not matter what naming convention you use. But it is usually recommended to be consistent with the same naming convention that you use on a certain script. So if you have a lot of Python scripts that follow the snake case naming convention, then of course it's a good idea to keep using that naming convention and staying consistent, just because it shows that you're professional with your code, you have good practice, and if you are trying to get a job somewhere in programming with Python or any language, it shows them that you know what you're doing. It shows that your code just isn't out all over the place. Having consistency shows that you made your code and it's not made by some AI or whatever. And it's just generally a good idea to be consistent. Now, earlier I said be descriptive. So, for an example, score underscore text is a good name for a score text. So, like 40. If we were putting that text on a screen or like a GUI or GUI, UI, whatever you call it. Or we could type in something like start score. That's also a good name. Now, when I say be descriptive like we are now, I don't mean go overboard with how your variables are. So don't ever do something like starting score of player when they join the game. While this works, it works like a variable, it'll execute just fine. There's no reason to have a variable that long. You can just have starting score, or even better, start score, or even better, score. So while yes, you should be descriptive, do not go overboard in how you name your variables. And this goes the same for functions. So if I want to create a function, which I know we haven't talked about yet, but just giving a name like this, say function, or a class, something like that. Those also follow that same naming convention as well. And that's also another reason why you should be consistent. If your variables are using snake case, make sure your classes and functions are using snake case as well. If your functions are using Pascal case, make sure your functions, classes, variables, whatever, make sure they use Pascal case as well. So the main takeaway from this segment is be consistent with your naming convention, make your code easy to read, and be very, very descriptive with your variables, classes, and function names, as well as your file names as well. And another thing that's important is it's a good idea, but not necessarily with naming convention, but it's a good idea nonetheless. If you don't feel like you can make your variable more descriptive than what it already is, you can always just add a comment. Starting score at beginning of game. That works perfectly just fine. That way, whoever is reading your code, even though your variable may not be as descriptive as you want it to be, they can still figure out what that variable's for. So that's not really pertaining to naming convention, but it's a good idea and a good tip to know anyways. But that's it for this segment, and I'll see you guys on to the next one. Alright guys, now let's talk about data types in Python. Now, there are quite a few data types. 3 of them we have already talked about so far in this course, and that's the integer or int, float for a decimal number, and a string for text. Now, there are obviously way more than these 3 data types, but of course, these 3 are the very big ones that we use in all of our scripts most of the time. Now, what exactly is a data type in Python? Well, a data type in Python and also in other programming languages as well is just the type of value that we have associated with a variable, whether it's a whole number, otherwise known as an int, or an integer, or a float, which can also be called a double in some other programming languages, or maybe a list, or a string, or a set, or a tuple, a bool, an object, a complex, a dict for a dictionary, or what's also called an associative array. There's a lot of different data types in Python. Now, what I have here is just some basic data types that we see quite often in Python. Of course, int, float, and string being the most common. Lists also being pretty common on certain scripts. Sets and tuples, they work like lists, but they have some differences, which we'll talk more about when we get into collections. We also have an object, which is created with a class. And they have properties or attributes that we can change. An example of this is like a car, a house, a person, a player, a ball, a cube, whatever it may be. There's also a bool, which is a binary value. It could be 1, 0, or true or false, which actually if we were to type in like x plus true and x was equal to 8, we would actually get out 9, because when we say true, we're meaning just 1, and false, we are meaning 0. So basically, whenever we're working with a binary value, we're doing it through a bool or boolean, which is just true or false. An example of this is like a variable, will viewer subscribe, and we could set it to true, because, well, honestly, if you enjoy this kind of content, you should definitely subscribe to my channel for more just like it. But those are our most common data types. Now, to kind of go with our naming convention segment we just got done with, we can name something like my age, and if we want to essentially type hint it, which is basically writing the data type next to the variable and then setting it equal to a value, just to improve readability in your code. We could do something like my underscore age colon int, and then setting it equal to 19. Now, when I hover over this, if your IDE is fancy like mine, you have my age, and you have 19 here, and we know that this is an integer. And of course, if I wanted to print my age, and let me just navigate to my Python file. Or whoops, yep, cmd python main.py. Prints out 19, so it doesn't change how your code is executed, but as you can see, if you were reading someone else's code and it was pretty complex, you can instantly tell that this variable is meant to be an integer. We could also just type in float if we wanted like 19.123 or something like that. If, for an example, is script running, if it was supposed to be a bool, we could type in colon bool, set it equal to true. We could do message string, which is denoted as str, and we could set it equal to hello world, And of course, if I wanted to print out that message, of course, doing it correctly with correct syntax. As you can see, it prints out no problem. So this is basically all that data types are. It's just a type of value we have associated with the variable. So if our variable is dealing with a whole number, then, well, it's going to be an integer or int. If our variable contains text or any ASCII or ASCII characters, it would be known as a string, or what's denoted as str inside of Python. We also have floats for decimal numbers, bools for Boolean values, true or false, object for objects, lists for lists, sets for sets, tuples for tuples, and stuff like that. There's a lot of data types we can work with. Now, we can also convert data types and such. Let's say I had a input here, or let's set x equal to an input, and enter a number, just like that. And I wanted to print x. Run this code. And I'm just going to do this in Visual Studio, but enter number 5, and we get 5 in the output here. But what if I wanted to do some math with that? Well, you may know that this function input returns a string, meaning whatever value we input in our console, it's going to give us a string value of x. So this x is going to become a data type. But we need to do math with this. So what if I want to do print x and then plus 5 in here? So if I run the code and I put in 7, we're gonna get a type error, and it's gonna say can only concatenate string, not int to string. So there's a problem here. We need to somehow make this input take in a number as a integer or a float, so that way we can perform math with it. What we can do here is we could type in int, then put a parenthesis there, and at the end, put a parenthesis here. Yes, you can actually type in int, and then parentheses, and then put in a number like 4, or something like that as a string, and it will convert it to an integer. So now if I go ahead and run this code, enter a number, 7, and then we get 12 in the output, because we converted that input into an integer, and we did math with it. Now, of course, what if I was to type in something else like that? Well, we're going to get a value error because, well, that's obviously not a number. Now, in this segment, we're going to just ignore that. We're going to pretend like it doesn't happen, and it can't happen, because, of course, in the future, we're going to learn some more programming and how to handle such an error like what just happened. So that's how we can convert data types. And of course, you could do this with a string or a float, even a bool for whatever reason you might have. It just really depends on what you're doing. But yes, you can convert data types. So if you have a string that contains like the number 5 and you want to do math with it, you can convert it to an integer or floats. That way you can perform your math operations. If for whatever reason you want to convert a number into a string so you can concatenate it and avoid that type error we just witnessed, you could just type in string 5. And now you have a string, and you store it into a variable like my string of 5. And we can print my string of 5, and now we have a string. How nice. That is basically it for this data type segment. For a beginner level, this is pretty much all we're going to cover. It's what we're all really going to see in this Python course. Of course, there are more like a complex data type which deals with complex numbers, but they're not very common. But though that will be covered in another course designed for more intermediate Python developers. But for a beginner level, we're mainly going to be working with the simple ones like string, integer, float, list, bool, object, etc. But moving on to the next segment now, we are done with data types. Alright guys, now we are going to be talking about collections in Python. Now there are 4 main collection data types in the Python language as the dictionary, list, set, and tuple. The dictionary uses names, or also called keys, and they are usually associated with a specific value. This is also known as an associative array in other programming languages. A list, on the other hand, is a collection of many different values with a specific ID, or otherwise known as an index position. Lists can have values of very many different data types, whether it be strings, integers, floats, bools, objects, or even other lists as well. Sets and tuples operate similar to lists, but there are some very key differences. Both sets and tuples are not mutable, meaning that after you predefine the set or tuple with its given values, you cannot change them later in a script like you can with a list or dictionary. In a set, you can only have a single element occur once in a set, meaning you cannot have the number 10 or the value 10 occur more than once in a set. A tuple, you can. Now, all collections are useful in Python, but it really depends on the project you are working on. Whether it be a dictionary or a list, a set, or a tuple, it really depends on what you're working on for you to decide which collection type is the best. In this segment, we're mainly going to be focusing on the dictionary type and the list type, but we will talk about a set and tuple as well. First, let's talk about the dictionary or associative array in Python. Now, a dictionary is a mapping array or a mapping type. And what that means is we create a name or a key and we associate it with a certain value. So whenever we want to access that value, we can access it by referencing that key or name. So let's say I have a dictionary and I'm going to call this person. And to create a dictionary, we just define a variable and we set it equal to a set of curly braces like this. And in here, we can go ahead and insert our keys using the string quotations, and then we can give it a name. And for the context of a person, we could type in something like first name. And then to actually give it a value, we'd exit the quotations, put in a colon, and then we could give it the value. And for this one, we can do John. We could also do last name and set it equal to Doe. And to add more keys, we add a comma at the end of our value here. We can do one for age. And we can say that he's 23 years old. And we can do one for gender. And we could say that he is a male. Now, at the last key and value, you do not have to be having a comma here. You do not need a comma, but you can put one just in case if you plan to come in here and edit more values. And that's because if I remove the comma after age, we get a syntax error here. But it does not matter if you put one or not at the last key. So now we have this dictionary or an associative array called person. And in here we have a first name, last name, age, and gender. What if I want to access the first name of this person? Well, we can type in a variable called first name, and we set it equal to person, then a set of straight brackets, and in here, we could just use tab to select the key that we want to access. And since I want to access the value for the first name, we would put in first name like that, or you can just type it in using the the quotations. And that's it. And if I wanted to print the first name, I can go ahead and just type in that, and then go to my CMD, Python main.py, and we get John. If I wanted to access the last name, I can just edit this to last name, run this again, and then we get Doe. Same thing for age, 23, and then you can guess what's going to happen if I do gender. Get male. Pretty neat. So that's how we can access values in an associative array or dictionary in Python. What if I want to change a value? What if I have the first name predefined as John, but let's say it's John's birthday today, and John wants to change his name? Well, what we can do is we could say John wants to change his name to Jimmy. All right. We can type in person, first name, and we can set it equal to Jimmy. Or whoops, I meant the string of Jimmy. And then let's say it's also now Jimmy's birthday. Type in person, age, and I can set it equal to person, age, plus 1. Or we can use a shorthand operator for incrementing by 1 by typing in plus equal 1. And then I can go ahead and actually just print person like that. And if I go ahead and run this script, we now have first name as Jimmy, last name Doe, and age 24 instead of 23. So pretty nice. This is known as a mutable array or mutable collection. Mutable means that we can reassign values to certain keys or index positions in a collection, whether it is a dictionary or a list. Now, we cannot do this in a set or tuple because those are not mutable collections. All right, let's say I don't know what keys or values are inside of this person dictionary. What I can do is I could type in keys and set it equal to person.keys with the parentheses at the end. And when we call this keys method, it's going to return us all of the keys that exist within this person. So I can type in print keys just like that. And now we get this dict keys object of first name, last name, age, and gender. All right, what if I wanted to print out the values of this person? I can type in values, change that to the values, and then just print values like that. And then we get the values of this person dictionary. So John Doe 13 male. What if I have this person predefined and I want to remove his gender? I want to make John Doe genderless. Okay, well, we can type in person dot pop, and then we pass in the key that we want to remove, and that will be gender. Then I can go ahead and print person. Go back to my CMD or command prompt. And now we have first name John, last name Doe, and age 23. So gender is no longer a key, and there is no longer a value for this dictionary. Of course, if I didn't want him to have a last name, I can just type in that and remove that none, because tab 9 is being stupid, and run this code again. And now we have first name John, age 23, gender male. So we don't have last name anymore. Now, there is also another method, and that is .items. And to actually print this out, we need to set a variable to that. And if I go ahead and print items, what this will do, this will return us a list of tuples containing the key and its associated value. So first name, John, last name, Doe, age 23, gender male. There's also some other methods like clear and copy. Clear will just get rid of everything in the dictionary. Copy will make a copy of the dictionary. There's also a get method. And basically what the get method does is we will pass in a string and we can just type in something like first name. And we inside this get method here, we can type in the string or the string of the key, which is just first name like that. And then, oops, let me get rid of that. We can just print it out. So to use the get method, we can get the value associated with a key by inserting the key name inside of here, storing it in that variable first name. And if we go ahead and run this, now we get John. Now, this is really just the first, or same thing as typing in first name is equal to person, first name. It's the same thing as that. There's no difference except this is using a method. Pretty nice. Now, let's talk about lists in Python. Now, lists, in my opinion, can be a little bit more complex, but they are very useful in programming. We can use lists to store a plethora of many different values, whether it's objects, numbers, perhaps you are trying to get the mean or median or the mode of a set of numbers. We could use lists to iterate through that numbers and then calculate the mean or median or mode based on those. Perhaps you want to get a sum of all numbers. Well, we can insert each number in a list and then we can use the sum function to calculate the sum of all those numbers. There are many different things we can do in lists. It really just depends on your project. But in a list, it can be rather complex depending on what we're doing. And it's really important to understand how a list works in Python from the syntax and its functionality. So to create a list, we could first type in a variable and we can call this my list. And we're going to set it equal to a set of straight brackets. And inside here, we can start inserting each of our values like 3, 1, John, true, and then 3.14, and hello world. So in a list, you can actually have multiple different data types in the same list. Now, in most programming languages, you cannot do this. A list has to have every element be the same data type. So you cannot do this in C#. I believe it's the same in Java, and I think most of the web dev programming languages as well. Now, what these are called, each of these values, they are called elements. And each element has an index position in this list. And its index position starts at 0. So number 3 here is at index position 0. 1 is at 1. John is going to be at 2. True is at 3. 3.14 is at 4. And hello world is at 5. And what this index position does is it acts as a unique ID to each of these elements. And if I want to get each of these elements or values, I can actually type in, for an example, value and set it equal to my list. And let's say I want to pull the name John. Well, I would type in a set of straight brackets, like if it was a dictionary, and I would just insert the index position I want to grab the value from. And John's index position is 2, so I'm going to insert 2 right here. And I can go ahead and print value. Go to my code, and I'm actually going to type in CMD again to clear that console. Python main.py, enter, and now we get John in the output. I want to access this Boolean statement here of true. I can do the same thing, and we get true in the output. Want to say hello world, so I'll put in index position 5, and now we get hello world in the output. Now, like I said, with dictionaries, lists are also mutable, so we can reassign values at a given index position. What if I don't want index position 2 to be John anymore? Well, I can simply just type in my list at index position 2, and I can set it equal to Jimmy. And let's say I also do not want index position 0 to be 3 anymore. I want it to be 4. Well, we can do my list at index position 0, and we can set it equal to 4, or we can use a shorthand operator to increment by 1 to give us 4. And now, all I gotta do is just type in my list, if I want to print the whole entire list. And now we get 4 instead of 3, 1, and then Jimmy instead of John, and then true 3.14 and hello world. Pretty neat. Now, like the dictionary, there is also some functions or methods that we can use with a list. I can type in my list.sort, and basically what this would do is, if these are all numbers, it would sort them from least to greatest. Now, I can go ahead and change these to like 2, 7, and then 9, and then let's do 14. I could type in mylist.sort, and if I go back to my command prompt, now our list is sorted from least to greatest. But what if I want it to be sorted from greatest to least? Well, what I can do is, after this list.sort, I can type in mylist.reverse. And if I go ahead and run this again, now it is sorted from greatest to least. And if I remove this, what I'll do is I'll just have it sorted like that. Or, well, not sorted, but it'll be flipped. So 14 will be at index position 0, 3 will be at index position 5, and you get the entire gist. It basically flips everything. There's also .copy and clear, which just create a copy of the list or clear the entire list. Not much of a need to really explain that. We also have .append, and what .append is, it'll add a new element to that list. And I'm going to fix these here. And basically, let's say I want to add a 6th index position, and I want it to be, I don't know, 27. Well, to do that, what I can do is I can type in .append, and in here I can just insert 27. And it will now add 27 as the 6th index position inside of this list. Or we could also say the 7th value. What if I want to remove something from this list? I can type in remove. And what it will do is we'll insert a value, and it will remove the first occurrence of that value. And basically what that means is, if I have 2 2s in here, then, well, it's going to remove one of them. And I want to remove this 3. I don't want 3 anymore. Now it removed 3, and 1 is now at index position 0, 2 is at index position 1, 7 at 2, 9 at 3, and 14 at 4. There's also count. And what count does is you can insert a element. So if I have 3 in here, I only have it once. If I insert 3 into count, whoops. Let me actually fix this. I forgot I need to associate this with the variable. Let's see. Count of 3s. And set it equal to my list.count3. And I can print counts of 3s. And well, 3 is only in this list once. It only occurs once, so we get 1. But if I go ahead and add 3 again, run this, we're going to get 2. There is also index. And what index does is we can insert the element and get the index position of that element. So let's say I want to get the index position of the value 9. And let's just say we don't really know that it's 4, even though it's telling us right there. Well, I can just insert 9, and then we get 4 in the output. And the last one I'm going to talk about is insert. And what insert does is it's going to insert an object or a element at an index position. So I can type in, let's say I want to insert 15 at index position 2. Actually, whoops. Let me print my list. And that's not an actual function. Tab 9 is just being stupid. Sorry about that. But now we have 3, 1, 2, 7, 9, 14. Oh, I actually did this wrong. Did it backwards. It's the index position first, and then the object. Okay, sweet. 3, 1, 15, 2, 7, 9, 4. So now we have 15 added in our index. Or in our list. So that's really it for lists. Now, we'll talk more about lists when we get into loops and iterations. But moving on, let's talk about sets and tuples. Now, the thing with sets and tuples are that you cannot change or reassign the values. Whatever they are predefined to be is what they're going to be for the entire script. So, unlike a list where we can just change or edit the values or elements, in a set or tuple, they are going to stay the same no matter what. So let's just change this to my tuple, and we set it equal to a empty set of parentheses, and in here we can insert a values. Now, what would you use a tuple for? Well, perhaps maybe you're dealing with a graph, and this tuple here is going to house a x and y coordinate. So we can say x is 50. 100 is the y value, or y is 100. So maybe you have a function and you want to create a tuple for every x value, and then its second or first index position here will be the y value or the output of that function. Another good use for them is if you were designing a GUI and you want to have a screen size. Well, you'd have the vertical size, or I'm sorry, this is the horizontal size. So you have your horizontal size, and you also may have your vertical size, so X and Y again. And these are really only good if they are not changing. If you do not need your values to change inside this tuple, then you're good to use it. If you do need your values to change, then you're better off using a list. Tuples can have multiple of the same value, so 2, 2, 2 again. The only difference between a tuple and a list is it's not mutable, so you can't change the values. Sets, on the other hand, are created using curly braces, just like a dictionary. But obviously, we're not going to insert a key and a value in here. What we are going to do is we're going to go ahead and just insert our values. And let's say I have 2 repeating twice. Well, if I go ahead and try to print my set, and for some reason tab 9 thinks it's a dictionary. And I go ahead and run this code. As you can see, we're just going to get 1, 2, and 3. We're not going to get 2 twice because it's going to omit one of those 2's. And the cool thing about sets is it automatically orders them. So it sorts them from least to greatest. And if I wanted to sneak in a 5 and a 4, even though it's in this order, 3, 1, 2, 5, and 4, if I go ahead and run the script, it's going to sort them automatically, 1, 2, 3, and 4, and 5. So again, what might you use a setter tuple for? Well, honestly, it depends on the project. Personally, I like using lists, even if it's just a couple values, because a lot of my projects are pretty dynamic and they involve lists with changing values or elements. But that is really it for collections. Our main focus was dictionaries and lists because those are the most common collection types that we use when scripting. But moving on to the next segment, we can now actually deal more with lists through things such as iterations and loops. Alright guys, now on to loops and iterations. In Python, there are 2 types of loops, a for loop and a while loop. Now, if you've programmed in other languages, you may be familiar with a loop called a for each loop. Python does not have a for each loop because it is essentially merged within the for loop, and if we want to use for or for each, we just set it up differently. Now, in this segment, we're mainly going to be talking about for loops, because to truly understand how a while loop works in Python, we first need to understand the basics of conditionals and conditional statements. But first, let's talk about what a loop does. Well, in programming, a loop essentially repeats lines or blocks of code until either A, an iteration is complete, or, in other words, reach the end of a list, or if a certain condition is met or no longer met. Now, depending on what kind of loop you're going to use, it's really based on the project you're working on. If you're dealing with lists, then you're more likely going to need to use a for loop. Now, if you just want to repeat certain lines of code, or if you're designing a GUI that's going to keep a program like this text editor, Visual Studios, on the screen, or a GUI like my recording software on the screen, or maybe a GUI like Firefox. Anything, no matter what it is, you may want to use a while loop for it because it's going to keep things on the screen until you terminate the program yourself. So, before you decide or start writing down what loop you're going to need, be sure to ask yourself the question, what is your project doing? Which type of loop may be best for you? But in this segment, like I said, we're going to be mainly worried about for loops, and then we'll talk about while loops after we get through conditionals. So let's say I have a list of numbers here, and I'm just going to call this numbers. And it's going to be 1, 2, 3, 4, 10, 5, 7, 9. See, that is 8 numbers. Okay. And I want to print every single number in the output. Well, what we can do is we could type in something like number 1 equals to numbers in the index position 0 where 1 is at. And we can just keep doing this for number 2, number 3, number 4, number 10, number 5, number 7, and so on and so forth. But that's pretty repetitive, and it's extremely unnecessary. We can simplify this using a for loop. To create a for loop, what we can do is we can type in for number, or num for short, in numbers. Essentially, what we are doing with this syntax is we are creating a variable num. It could be number, it could be in, it could be K, it could be A, B, C, D, E, F, G, whatever you want to call it. Basically what we're doing is we're creating this variable here, and we are associating it with every element in our target list or collection, which in this case is the numbers list. So what we are doing is we're creating this variable num, and we're associating it with every element in this list here. We're associating it with 1, 2, 3, 4, 10, 5, 7, 9. And if I want to print each of these numbers, I can just type in print num. Now keep in mind, I can't just type in print num here, because it is not in the same context of that for loop. And what I mean by that is, inside this for loop, we have a new context. And num is all of these elements. But if I'm not in the for loop and I try to print num, Python's not going to understand that I'm talking about these. Instead, what it's going to do is it's going to throw me an error. But let's forget about that for a minute, and let's just go ahead and go to our command prompt. And whoops. Python main.py. Copy that and run it. And as you can see, what just happened there is it printed out every single number in this list. Whereas we would have had to type out 8 different print statements. And if we create variables for them and then print them out, then it's going to be 16 extra lines of code where we don't really need that. Well, technically 14 extra lines, but still, it's unnecessary. We can simplify this with a 2-line for loop. Now, here's a for loop that will probably be the simplest for loop you'll ever see. And that is the for I in range loop. Now, what does this range object do? Well, it's going to create us a list that we can iterate through using the variable I. Same syntax as for num in numbers. But instead of inserting a list we created, we're using a object called range to create ourselves a list. So we can insert a starting value like 10 and an ending value, or I'm sorry, a starting value like 0 and an ending value like 10. And I can type in print I, go ahead and run this code, and we get 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, you're probably wondering, well, why didn't we get 10? We should have gotten 10. Well, the thing is, in a range loop, the last value, the ending value, cannot be greater than or equal to the end value that we insert in here. So if you are writing a function and you are wanting to create a better range loop that goes ahead and inserts this number here, you might use an argument like n, and we can just type in n plus 1, and which would be 11 if we chose 10. And if I go ahead and run this again, as you can see, we now have 10 included. There's also an increment value, which by default is 1 if we don't specify it, but we could set it to like 2. And if I go ahead and run this again, we now get 0, 2, 4, 6, and 8. And it's stopping at 8 because after 2, again, it'll be 10, and it cannot be equal to or greater than this number here. So that's a for I in range loop. And why might you use this? Well, basically, it's for repeating blocks of code a certain number of times. So similar to a while loop, but we want to repeat it a specified number instead of based on a condition. Now, you're probably wondering, well, if I put in 10, is it going to repeat 9 times? No. And that's because if we go here and count, as you can see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 different numbers because the rule for the range object is it can start at 0, insert 0, and then count up to 10, but it cannot be equal or greater than 10. So we have 10 different numbers here. So if we have a block of code like print hello world, and if I want to insert 5 instead of 10, it's going to print hello world 5 times. So pretty neat. Now, let's say I have a list of people. I can call this people. And inside here is going to be John, Jim, Andrew, Sally, and let's do Nate. 5 people. Yep, 5 people. And these 5 people have an index position. But what if I want to keep track of that index position while I'm iterating through this list? Well, we can do for person in people. And we can print person. But there's an issue with this. And when we go to run this code, we're just going to print out each person's name, or each person if they were an object in Python. But we can't keep track of their ID this way. So how are we going to do this? Well, there's another type of for loop called an enumerate loop. We can type in for index person and enumerate people. So now we have 2 different variables. And let me get rid of this comma here. That is not correct syntax. So we have 2 different variables, index and position. We're assigning index to the index position of person. And I'm pretty sure I accidentally said position when talking about a person. I apologize about that. So basically what this is going to do is we're going to iterate through person as if it was a normal for person and people loop. The only difference is we're assigning index to that person, and we're doing this through the enumerate object. So if I wanted to, I can type in print person, and I want to make this an F string. Put in person here, put in a straight line, and then index position, pause for short, and we can just insert index right here. If I go ahead and run this, we now have person, John, Jim, Andrew, Sally, Nate, and then we have the index position 0, 1, 2, 3, and 4 for the respective person. So if you want to keep track of the index position so we could use it as a unique ID for each person, we could do that through using an enumerate loop. So that way, if for whatever reason we want to access these people through the index position later through the .index method, we can do so by keeping track of all these indexes. And that's really it for the simplest of loops. Again, for loops can be used for many different things depending on the project. Maybe you have a project that goes through all kinds of files on your computer, and maybe you only want to go through certain file types. Maybe you have multiple text files and you want to create a list of those text files, and you want to iterate and sort these files, or these text files, I should say. And maybe you don't want to do anything with the .py or Python files. You can use a for loop to iterate through text files and skip the Python files if we create a list of all files in a single directory. We could actually do this later on when we get into the OS module of this course, where we can actually get a list of all files in a specified directory, and we could test this out by using a for loop and only printing out the file paths of all text files, for an example. So that's pretty neat. That's what we can use for loops for. If we have multiple objects in a list and we want to perform certain actions using objects as methods, we can do so using a for loop instead of writing down object dot whatever method over and over again. So that's pretty cool. For loops are very useful in Python, and I highly encourage you guys to try and incorporate them in any projects. But that is all for this segment, and now we can move on to the next one. Alright guys, now we're going to be taking a look at conditionals in Python. Now, what is a conditional? Well, in programming, a conditional is a statement that will run or execute a certain block or line of code based on a certain condition being met. Now, where would you use conditionals? Well, you could use them in just about any scenario. Maybe you are wanting to compare values of two or more variables. Or maybe you want to compare a value of just a single variable. Maybe you have an event listener in your program and you are listening for a certain event to occur. And if that event does occur, then maybe you want to execute some lines of code. In that case, you would use a conditional statement. So there are a lot of different scenarios where we are going to be using conditionals in our projects. Now, before we get to writing our conditionals, it is important to know essentially the anatomy of a conditional. So we start our conditional by typing in the keyword if. And our conditional is going to come right here after the if. And it can be if x is equal to 3, or if x is greater than 3, or if x is not equal to 3. And I will show you how to use these operators later on. But there is also two other operators that are very important, and we can use them to merge multiple conditional statements together to have a single output. And that is the and or operators. Now, if you have played around with digital logic, or if you have used and or gates on a logic board, then you may find this very familiar. But right here, I have just pasted a simple diagram of the and or operators and the outputs listed based on the inputs. Excuse me. Now, before we get started talking about this, let's take a minute and note that whenever we see a 1, we are really saying true. And whenever we see a 0, we are saying false. Now, let's also take a look at what the and or operators are and what they mean. Whenever we use an and operator, all conditions in that single conditional statement, whether it's x and y, a and b and c, x and y and z, w, whatever that is, they all must be true for the output to result in true. Or, in the case of programming, all of the conditions must be true for the code under the statement to be executed. Let's talk about the OR operator. So the OR operator is similar to the AND operator. We use it to combine multiple conditions together. But what the OR operator does is it is only looking for one of the conditions to be true. So if we have x or y, and x happens to be true, but y happens to be false, then z will still be true, and in the context of programming, z will output the code. So if you have 10 different conditions and you're using an OR operator, you only need one of those conditions to be true. If you have 10 different conditions and you're using the AND operator for all of those conditions, then they all 10 must be true. They all have to be true for the code under it to run. Excuse me. So, let's look at the diagram here. So again, 1 is true, 0 is false. So we have x and y. X is true and y is true, so what is z? Well, z is going to be true because we have fulfilled that requirement for the AND operator. Both x and y are true, so therefore z is true, and in the context of programming, we will execute the code under that statement. X is true, but y is false, therefore z is also false, and the code will not execute. And the third row here is basically the same thing, but reversed. X is false, but y is true. Z is going to be false. In the fourth row, we have x and y both being false, and therefore z is also going to be false. And that, my friends, is the AND operator. Now let's look at the OR operator. So remember, the OR operator states that only one of the conditions has to be true for the output to be true or for the code under the statement to be executed. So we have X or Y. X is true, Y is false. Since one of those is true, then that means Z is going to be true. X is false, but Y is true, so therefore Z is also going to be true. X and Y are both true, and since that rule is still fulfilled, that means Z is going to be true. X and Y are both false, so therefore Z is going to be false because none of those happen to be true. Now there is technically another logic operator, and that's called the not operator, but essentially what that's going to do is it's just going to flip or basically invert all of these values. So this 1 would become a 0 and this 0 would become a 1, which we'll show, or well, I'll show and we'll talk about later on in this segment. So now that we have that in mind, let's go ahead and start building conditionals. So let's say I have a variable x and I want it to be set to 12, and I have a variable y and I want it to be set to 13. And I want to check if x and y are both equal. Well, I could type in the keyword if, which by the way, this is how we all start conditional statements. We use the keyword if, and then I could type in x equal y. This double equal sign is the equal to operator. Do not get it confused with a single equal sign because that is the assignment operator, which is what we use up here to assign values. So whenever we want to check if 2 or more values are equal, we need to use the double equal to sign. And then we can add a colon, and then we want to indent under this if statement. And then we can go ahead and type in the code that we want to be executed in the event that x and y are both equal. So we can type in print x and y are both equal. And I can go ahead and run this. I'm going to do it in my terminal. But notice nothing happened because x and y are not equal since x is 12 and y is 13. But what if I go ahead and change y to 12? And we can run the code again. And as you can see in my output down here at the bottom, I get x and y are both equal. What if I want to check if x is greater than y? And for that, I will just change y to be 6. Alright, so what if I want to check if x is greater than y? Well, we can type in if x, and then we can use the greater than symbol to check if x is greater than y. And then we can type in print x is greater than y. Run the code, and as you can see, we get that statement printed into the output. If I want to check if y is greater than x, well, nothing happens because y is not, in fact, greater than x. So what just happened here? Well, basically, as I was talking about earlier, this condition right here just evaluated to be false. And we know that if it evaluates to be false, then the code down here will not be executed. And my IDE actually kind of grayed out this code here because now it's technically unreachable since this will never happen to be true ever again. And if I go ahead and type it to be true, then this code will always be executed. And I can just show you. If true, there you go, change it to false, and we see nothing happens. All right. Now, what if I want to create a conditional statement that later performs another conditional statement if the first one happens to be false? Well, that's where the keyword elif comes in. So let's say I have if y is greater than x, print y is greater than x. And if I have an elif statement here with another conditional, what I can do is I can type in if y is less than x, Now, essentially, what will happen is when we execute our code, it will run this first conditional statement here, and it's going to check if y is greater than x. Now, looking at our variables here, we can go ahead and predict that this first conditional statement, this if statement here on line 5, will not execute because 6 is not greater than 12. So what will happen is it will go ahead and move on to this elif statement, checking if y is less than x. And we can go ahead and run the code. And as you can see, we get this output right here instead of this one. So what happened was this evaluated to be false. So it moved on to next statement, which is this elif statement checking if y is less than x, and this actually outputted to be true. So pretty nice. Now, what if I just go ahead and type in if? Well, it would work just fine. And actually, we can go ahead and run this code, and as you can see, well, if I go ahead and change that, as you can see, it still executes normally as if it was still elif. So what's the difference between just typing in if over and again instead of just if and then elif afterwards? Well, essentially, the issue can come into play if you are creating a program that is performance heavy. If you're just creating a program where you want it to run really fast, not have to face with any lag, not have to face with any memory or CPU issues, you want your program to be very good on performance. In that case, you would want to tie all of your if statements together using one if statement and then the rest are elif, if it's in the same context. So let's say our context here is we're wanting to compare x and y. We're wanting to check if they're not equal, if they're equal, if one's greater than the other, or the other's greater than one, stuff like that. We want to tie them using an elif statement after our first if statement. Now, if we are doing another check, like message is equal to hello world, that's completely different. It's a different context, has nothing to do with this. So if I wanted to actually check if that message is equal to hello world, instead of typing elif message is equal to hello world, what I can do then is I can just give some space. That way we know it's a different statement, and then we can just leave that as if. And now we have two separate if statements. So why might you do this again? Well, it really just depends on the program. It's better coding practice if we tie our conditional statements together, if they're in the same context, because of performance. It saves us memory, it saves us CPU, and it overall makes our code look more professional, because if we are joining the workforce, if we're designing an application for somebody, we want them to be happy with the performance. We don't want to give them bad code and then their application possibly run into some issues later on down the line. So if you're comparing two or more values, or if you're just comparing one value, whatever it may be, if you are having multiple conditional statements in that same context, tie them together. If you can, tie them together. It makes your code look better, it's better practice, and it can be pretty helpful performance-wise. But obviously in a program like this, it doesn't really matter too much, because let's be honest, this is just a simple console-based application. You know, performance isn't really a priority here. But you understand what I mean, especially if you're making something like a video game, perhaps. You might want to keep this in mind. So what does elif really do? Well, whenever we have our first if statement, basically what's going to happen is, I'm actually going to copy and paste this. Let's say we have multiple elif statements after this single if statement. Well, let's say this if statement on line 7 evaluates to false. Well, it's going to move on to this elif statement, sorry. And if this evaluates to be false, then it's going to move on to the next one, and then the next one, until it reaches one that evaluates to be true. But in the event that none of these are true, then what are we going to do? Well, there is a default mode we can set here, and it's called the else statement. And we want to use the else statement specifically in the event that none of these conditionals here evaluate to be true. So by default, we can do something like none of the conditions are met. So let's see, we could type in equal. Let's actually, so let's set both of these to 0 if y is greater than x, and then if y is less than x, and then we'll do an elif if y is not equal to x. And then we can print equal to x. So we're now checking if y is greater than x, and then if y is less than x, and if y and x are not equal to each other. So as we can see, we can predict that this if statement's going to be false, this one's going to be false, and then this one is going to be false, because they're both the same number. They're both 0, so we can't use greater or less than. So those two are going to be false. And this one's checking if they're not equal, in which they are. So this is also going to be false. And if I go ahead and run this code, we now see that this else statement has evaluated to be true. And then we have gotten in our output that none of the conditions are met. So basically, in the event that none of your if or elif statements are true, it'll default to this else statement, which you can have it execute the code that you need it to be executed. So that's really it with if statements. But let's go ahead and add in some ors. So let's set y to 3 and then x to 6. If y is equal to 6 and x is equal to 3, then what we can do is we can print y is 6 and x is 3. And since x is 6 and y is 3, and I actually have those numbers flipped. Whoops. Sorry guys, I'm a little bit dyslexic, but now we're checking if y is 3 and x is 6, and if so, then we're going to print that statement to the console. And what do you know? It works. And that is because y is indeed 3 and x is indeed 6. And if you remember our discussion about the AND operator, all conditions must be true. And in this case, we have two conditions here, checking if y is 3 and x is 6. And they both evaluated to be true. So what we really have is if true and true. And since an AND statement says all must be true to execute the code under the conditional statement, we essentially have done that because they are all indeed true. So let's go ahead and try this OR. So now we're checking whether or not y is 3 or x is 6. And I can change it there. And if I go ahead and run this, y is 3 or x is 6. And it still ran just like the AND statement because both of these are evaluating to be true. But let's change x to 5. So now we're checking if we're checking if y is equal to 3 and x is equal to 6. But up here we have x defined as 5. It is still going to run because now this is true and this is false. But to remember, an OR operator only needs one of the conditionals to be true. But if I go ahead and change y to be 4, as you can see, nothing happens because this evaluates to be false and false. What if I go back to AND here and I check for y to be 3, but x is still 5 and it's looking for it to be 6? Well, we notice nothing happens because this is true and then this one's false. And remember, and requires all conditions to be met or all conditions to be true. And since one of them is false, this will not execute. We could also mix and or together. So what if I have A is equal to 4 and then B is equal to 7. And I want to check if B is greater than A and A is equal to 4, or B is less than A and Y is equal to X. Now, this looks a little weird, but basically what we're doing is we have combined 4 different conditions into 2, and it's split at this OR operator here. So we could actually wrap these around in parentheses just to make it a tad bit easier here. So this is one condition, and this is one condition instead of them being 4 different conditions. And basically, we're checking for A to be, or for B to be greater than A and A to be equal to 4. So we want to make sure B is greater than A while A is also 4. And then we have or B is less than A and Y is equal to X. Now, let's take a look at our variables. So B is 7, A is 4. So this is automatically true because 7 is greater than 4, of course. And then we're checking if A is equal to 4, and which it is up here. So this is true. So we can go ahead and type in true. True. Now, let's evaluate after this OR statement here, or I'm sorry, OR operator. Now we're checking if B is less than A. Well, it's not, so this is going to be false. And then we're checking if Y is equal to X. And, well, they're not equal, so this is also false. And then we can just print hello world. Whoops, sorry about that. And then we can just print hello world if this evaluates to be true anywhere. And since we're using OR in the middle, we're only looking for either of these to be true. And it is, because this is true and this is true. And since these are combined into one single conditional, this entire thing right here is true, while this one is false. Okay, so what if I want to check if A is equal to 5 here instead of 4? And I want to check if Y is equal to 3. We can go ahead and run it, see what's going to happen. And nothing happens, because now we have true and false here, and we have false and true here. And remember, an AND operator states that all conditions must be true in the same scope or same field. And in this field, we have 2 conditions, and one is true and the other's false. And same thing on this side here, so those will not work. But what if I go ahead and change that to an and change this to OR? So now we have an OR operator in both of our now combined conditionals, and we have it split down the middle at AND. What do you know? It executes. Since we switched the AND and OR around, we're now checking if this is true or if this is true. Well, one happens to be true while the other's false, so this still passes because it's an OR operator. This is false, but this is true, so this still passes because this is an OR operator. And basically what we have here is now true and true. And remember, for an AND operator, I know I keep saying it, but for an AND operator, all must be true, and this is true, and this is true. So therefore, this whole thing is true. And it will print out hello world. How lovely. Alright guys, now we're going to be talking about match and case in Python. Now, if you've programmed in other languages, you may know this as switch and case. This is basically the exact same thing, and match and case are an extension of if statements. But what we can do in match and case is we can use them whenever we are only dealing with one variable. So if you just need to compare x to another value rather than comparing x to y, we can use a match and case in that situation. Now, you may not be finding yourself using match and case that often, and that's okay, but it is pretty useful to know because there might be some instances where you just need to check one variable to match a certain value, which is where it gets its name from, and we can have our program execute specific lines or blocks of code based on that value. So let's say we have a variable called x, and we can set this variable to 3. And I want to make sure that this variable's value falls between 1 and 5. So x should only be between 1 and 5. And what I can do is I can type in the keyword match and then x colon indent. And then what I can do is I can start typing out each of my cases for what x could possibly be. So I can go ahead and type in case 1. X is 1. And let me make that lowercase. And then I can type in case 2. Case 3. Case 4. And then case 5. And if I go ahead and change this, or run it, I'm sorry. As you can see, we get x is 3. And if I were to go ahead and change this to 4, we now get x is 4. So it's running one of these cases based off of what value x is. Now, what if x doesn't fall between a range of 1 to 5? Well, nothing's going to happen, but we can add an extra component to this match and case system to ensure something will happen if x does not fall between 1 and 5. So what we can do is we can type in case, ace, same thing. We can type in case underscore and then a colon, and then we can type in print x is not falling between 1 and 5. And essentially what this underscore does, this is a special syntax that's really only native to Python. And basically what this does is it acts as a wildcard. And in the context of match and case, this is basically saying, okay, if x is neither of these values, then run this. And if you noticed how I explained these things, this is basically the same thing as typing in if x is equal to 1, or if x is equal to 2. And then it'll just keep going until else. Basically, it looks exactly like that. So now if I have x as 7, we can go ahead and run this code. And as you can see, now we're getting a message here, x is not falling between 1 and 5. Pretty nice. That is it for match and cases, and we can now move on to the next segment. Alright guys, let's talk about functions in Python. Now, in this course, we've seen functions already. We've seen the print function, the input function. We've seen plenty of methods, which are kind of like functions, but are dealing with objects. So we've seen those when we were on our arrays and lists part of this course. We've seen, well, we may have not seen the pal function, but this is a pal function in Python. It's native, and we can use it to bring in a base to an exponent. There's also a round function for rounding numbers. We've seen the range function, which is more technically an object, but we can call it a range function because typically we're using it in a function-like syntax. There's also enumerate, which is same situation as the range. So there's a lot of functions and methods in Python. Now, functions and methods are different. Methods are associated with an object, whilst functions are not. And in this segment, we're mainly going to be talking about functions. But when we get into object-oriented programming, we will talk about methods then. But first, how do we create a function? Well, we first start by typing in the def keyword, which just means define. And we use it to define a new function. Now, you want to give your function a name that pertains to what your function is doing. So for an example, if you're making a basic math function that adds two numbers, then, well, we probably should call this add underscore two nums. Or, if you want to keep it short and sweet, we could just call it add. And what we can do is, we can type in print, and then let's say we want to print the addition of 4 plus 5. And if I go ahead and run this, you'll see nothing happens. Why? Well, we've defined our function and we have scripted what our function is supposed to do when called upon, but we never called upon it. To call upon it, all we have to do is just type in add and then a set of parentheses right after. Run our code, and now we get 9 in our output from 4 plus 5. Now, this is a static addition function. It's hard-coded to add 4 and 5, but what if we want to add our own numbers? Well, we can type in add again, and in here we can insert what's called parameters or arguments in Python. And we can just define the keywords for them. And if we're adding two numbers, we could just type in x and y. And then we can just print x plus y. And now, when I call the add function, I can go ahead and insert my values 3 and 6 for an example. Run the code, and now we get 9 in the output. We can also define our values using keywords. So I can type in x is equal to 2 and y is equal to 6. Run our code. We will get 8. And we can actually do this backwards if we wanted to. Like that. So instead of defining x first, we're going to define y first. And this is only supported if we're defining our values through keywords. If I were to remove these, of course, we're going to get 8, but it's going to set x as 6 and y as 2 instead of the other way around. Now, it's not really the greatest practice to just sit here and have it print out what x and y are. What we should do is return x plus y using the return keyword. And we can just type in x plus y after. Now, what does return do? Well, it allows us to actually set a variable like z, for an example, to equal to the function add, and then we can add in our numbers like 5 and 2. And essentially what will happen is, it'll set x to be 5, y to be 2, and it will return the addition of 5 and 2. So it will return 7, and it will store the number 7 inside of this z variable where we can use it later. So if I go ahead and print z, we now get 7 in our output. Now, what if I'm designing a library of functions for other people to use? Well, in an IDE, if you hover over a function, it might give you a general description or a general diagram of what your function has and what it returns. But this is not very useful. Any, and any. That means we can have any data type in here, and we don't want that. You want to specify specific data types to be used. So what we can do is we can type in our variable or our keyword here, and we can type in a colon and then specify the data type that this value should be. And in the context of math, we really want to be dealing with either an int or integer or a float. Usually, we would want to deal with a float because it allows us to have support for decimal numbers. So we're going to do this again for y. And then we're going to specify the return value by going in between the colon and parenthesis here, typing in a minus sign and a less than symbol to form an arrow, and then we're going to type in the data type that is expected to be returned. Now, when we hover over this, whoever is using this function now knows that this function needs two floating point numbers, x and y, to return a floating point number. And if I were to go ahead and type add down here, as you can see, it will do the same thing. And then we can type in 3 and 4, set it equal to z, of course, and then print z. If I hover over z, it is now a float because that's what the return value of this add function is. But if we go ahead and run it, as you can see, it works the exact same. This is just better practice when creating our functions, because if we're designing a library, it helps people understand what to expect in the output from this function. Now, what if we have a rather complex function and we want to instruct people on how to use it? Well, what we can do is, at the very top of our function here, we can add a triple quotation, or otherwise known as a docstring. And with that docstring extension we just installed at the beginning of the course, we can click this button or hit enter here, and we can generate a template. And we can add a summary, a description of our arguments, and a description of our return value. So we can type in fill in values for x and y to obtain a sum of x and y. And we could just type in number 1 for x and number 2 for y. And we can type in sum of x and y, or number 1 and 2. And when I want to use this function later, I can call it, hover over it, and now we have this little short description or set of instructions on how to use this function. Now, you don't really do this unless you are making a library, but it is optional if you want to do it for yourself too. Just in case you have a lot of functions and you may not remember what this one does, you can hover over it and it will show you those notes there on what that function is for. Lastly, I want to talk about default values. Now, what if I were to type in z is equal to add and I just put in 1 and I try to print z? Well, as you can see, at this line 5 here, we receive an error in our output, and it says type error, add function missing one positional argument, y. Well, basically what happened was it's expecting a y value to be fulfilled. So when it's trying to return x plus y, it's really returning x plus, or 1 plus nothing. And, well, we can't really do that. That's not how math works. So Python's going to throw us an error. Now, of course, what we can do is set a default value. So up here, after this little float type hint, we can type in equals, let's say 1. And now if I go ahead and run this code, we're going to get 2 in the output, because what happened was we specified x, but we didn't specify y, so what this function did was it assumed y to be equal to 1. And just to show this even more, we can just type in 3, and as you can see, we're going to get 4 in the output. Now, of course, you can set this to be whatever number you want, and usually we see default values more common in functions that take in Boolean values, so like true or false, to specify certain things that may occur in that function. But this makes the y variable or y arguments optional. We don't have to fulfill y if we don't want to. And you can make all of these functions arguments optional if you want, but there's not really a case where you would. Maybe there is, but I've never really seen a reason to make all of them optional. I always leave at least one required if I have any arguments. But that's how we can set default values for arguments like y in case we don't want to specify y. And that's really it about functions. Of course, you can design more complex functions later on. Maybe your function's going to call another function like round or range. Or perhaps it's going to call something like an object. Maybe we're going to have this function create a new object or something. Not really sure. There's a lot of things you can do with functions, but it's important to know that these functions play a key role in how your script is going to work, and it can allow you to create certain functions of your program. So if you're designing something like a GUI and you have a button and you want something to happen when you click that button, because why wouldn't you? Well, you would tie a function to that button, and when you click it, that function will be called and it will do whatever you need it to do. So that's a pretty good use case for functions in Python, and there's actually a library that allows us to create GUIs, but we're not going to talk about it in this course because it's more an intermediate level. But I have done videos in the past on that library and how we can create custom GUIs and such. But enough rambling, that is it for this segment, and we can move on to the next. Alright guys, now that we have a basic understanding of conditionals, we can now talk about while loops in Python. Now, if you remember earlier in this course, we already discussed while loops at a bare minimum amount. So let's talk again about what while loops do in Python and what we can use them for. Well, while loops are similar to for loops in terms on how they repeat code over and over again. The main difference is that a while loop repeats code based on a certain condition being met, which is why we needed to run through conditional statements first, so that way we have a better understanding on what's really happening in a while loop. And what can we use these for? Well, we know that they're used to repeat lines or blocks of code, but we can use them for keeping GUIs open, we can use them in quiz games, we can use them in algorithms, we can use them to do math, we can use them in solving series. There's a whole lot of things we can use while loops for in Python, and not just in Python, but in programming in general. So first, let's talk about a conditional statement. Let's say, for an example, I have x is greater than y. Now, we know that this x is greater than y can only turn out to be true or false. That's how a conditional works in programming. That is our logic of our code. It can only be true or false. So whenever we type in while, and let's say for an example, x is greater than y, we are really going to be saying either while true or while false. And essentially what this means is if it turns out to be true, if we evaluate it to be true, then we're going to run the code under it. And if it's false, then this code under our while loop will not be ran. So in order for a while loop to work, the condition must be true. So let's talk about, what if I just set while true like that and type something in like hello world as a print statement? Well, when I go to run my code, you're going to notice that it's going to keep printing hello world. This is because that our condition is true, then this line is going to keep repeating over and over and over again. But if I change this to false and try to run it, nothing's going to happen. And actually, my IDE is smart enough to show me that this code is unreachable because it is a while false statement. So let's go ahead and actually make a condition for our while loop. So let's create a variable called x and let's set it to 5. And a y variable set to 0. And basically what we're going to do is we're going to type in while x is greater than y, print hello world. Let's run the code, and voila! It actually acts the exact same way as a while true loop. Well, that's because x is 5, y is 0. It's checking for x to be greater than y, so 5 to be greater than 0. So this is going to remain true forever until we start changing these variables. Now this is where we can begin to increment variables' values inside of a while loop. So let's say after this print statement, I want to add 1 to y. Well, I can type in y equals y plus 1. But we can shorten this by just typing in plus equals 1. Now, they both do the same way. Both ways you write it will do the same thing. It doesn't really matter, but this looks nicer, and to most people it's honestly easier to read. And it's just generally considered good coding practice. This is known as the add and assignment operator. There's also one for minus, multiplication, division, and modulus, and more. And I believe there's also one for exponentiation and floor division. But what we're basically going to do here is when I run this, it's going to run through this loop once, and then it's going to add 1 to y, so y is going to change to 1. Then it's going to do it again, change to 2, to 3, to 4, and then eventually 5. Let's go ahead and run this code. And well, as you can see, it ran 4 times, but that was actually a mistake because I left y as 1 predefined. So now it's running 5 times. And it's doing that because it's constantly checking this condition here, making sure it stays true. And well, once x and y become equal, this condition turns false, which will stop the loop. Which is why we stop at 5 instances of hello world. Now, what if I wanted to say if x is not equal to 5? And, whoops, forgot the exclamation point. Well, nothing's gonna happen. And let's do, actually, I written it wrong. What if y is not equal to x? Well, it's gonna run again, same way as that. And if I do equals, nothing's gonna happen. And the reason for that is because x and y are predefined up here, and we're trying to check if they're equal without even running the loop first. And even though if we were to run the loop like normal, they would become equal at some point, it's going to check the most recent assignment value that x and y had, which was 5 and 0. So it is checking for this. And obviously this is false, so this does not run. So enough of that. Let's talk about certain statements that we can use in while loops. So there's 3 of them. There is the return statement, which we also use in functions. There is the break statement and the continue statement. The return statement will exit the while loop and exit the function, all while returning a value in the outputs and setting it or assigning it to a variable that we declare. A break statement does the same thing as a return statement, except it does not return a value. It just breaks out of that while loop. And if it's within a function, that function will run as normally. A continue statement will actually restart the while loop over again. And we can configure using if blocks, try and except blocks, which we'll learn later, and even other while loops to determine if this while loop is going to run again. So I have two examples, one using the return statement and the second one using both the break and continue. So let's say I have a function here, def func for function. And in here, I'm going to define x to be 5 and y to be 0. Then I'm going to type in while true. And then I'm going to check if x is equal to y. And if it is, then we're going to return x is equal to y. And then for the else part, we're going to just type in y plus equals 1. And then I'm going to create a variable z and set it equal to func. And then we're going to print z. So we're creating two variables, x to be 5, y to be 0, and inside a while true loop, we're checking if both x and y are equal. And if they are, then we're going to return this string here, and if they're not, then we're going to increment y by 1. So let's run it. And it turns out that x is equal to y because we are incrementing it. But if I change this to a decrement, what will happen is, when I run this, nothing's going to happen. And it's going to keep running forever. Notice it did not say exit code. Because the code is not done running, it's going to keep running forever. We're just not getting anything printed to our output. And of course, if I wanted to, I could print y, just to show you what's really happening. And as you can see, we are already approaching negative 100,000 here. This is all happening so fast. This is how many ticks our code is running through. And we could use a time module that is pre-installed with Python to actually configure how often each tick will occur in this while loop. But our main concern is not about printing y or the tick speed of a while loop. It's about this return statement here. So this return statement worked. If I go ahead and just change this back to a plus equals, eventually we get x is equal to y. So we do run this line here. We run line 7 at one point because this condition eventually becomes true after y is incremented enough to be equal to x. But what if I want to print a little statement after it? Print hello world. Now, just ignore the fact that it's grayed out. That's my IDE being very smart. But if I run it, this never prints. That's because after a return statement, any code under it is completely ignored. It will not compile. It will not be ran. And what's special about the return statement inside of a while loop that is housed inside of a function is not only does it terminate the while loop, but it also exits the function and assigns the output value to a variable if we are assigning it to 1. And just to prove you that it will exit the function as well, we could exit this while loop and type in hello world. Run the code again, and as you can see, this line that's outside of the while loop but inside the function still does not run because we are returning a value before the compiler even gets a chance to see this line. Pretty neat. So that's how we could use the return statement inside of a while loop that's inside of a function. Keep in mind, you should only use the return statement if you are working in a while loop that's inside a function that is meant to return a value. If your while loop is inside of a function but you're not returning a value, then you're going to use break. And if your while loop isn't even in a function, then you're going to use break. Also, forgive me if I stutter a bit, I am a little bit sick, but keep in mind the difference between a break and a return statement is often overseen, but it is important to know the difference in how the two are used. Speaking about break, let's talk about break and continue. So let's say I have a while true loop. And I have an integer input, so x is equal to int input. Enter the number 1. And let's just say this is like some question for a quiz game. Then we're going to create a conditional if x is equal to 1. Then we are going to break. And I'm going to exit my while loop. And then, or actually, I'm sorry. I'm going to first print correct. And then I'm going to come down here and print exited while loop. And then elif x is equal to 0. Print incorrect. Try again. And now I'm going to type in continue. So, again, what does break and continue do? Well, break works similarly to the return statement, but what break does is it's going to just terminate the while loop, but it will not return a value, even if we use break in a function. Okay, what about continue? Well, continue restarts the while loop. So if this statement here becomes true, then we're going to print this out to the output, incorrect, try again. Then we're going to run this continue line. And what it's going to do is it's going to loop back to the very beginning and it's going to ask this again. And we can prove this. And I'm actually going to open this folder if I can find it. All right, I'm going to open this folder in my command, just so that way you guys can see this better. And Python main.py. Enter the number 1. Okay, let's say I want to enter 0. Incorrect, try again. Enter 0, incorrect, try again. Enter 0, incorrect, try again. But what if I enter 2? Well, it's just going to do that, but it's not going to run this message. Well, that's because if we don't explicitly check for 2, it's just going to restart the while loop anyways. It's going to basically run a default continue line. But what if I go ahead and print 1? It says correct, and then it's going to run this line 11. So what this break just did was it exited the while loop, concluded it, and moved on to the code under it, which is this print statement here. And keep in mind, if I were, I'm just going to run it in here now, but if I were to just print 1, as you can see, I can't do anything else. The program terminates, basically. So that's how we could use break and continue in a while loop. Now, depending on what you want to do in your while loop, it is important to think about what your while loop is doing before you choose which statement is best for your loop. If you're returning a value, if you want to store a value in a variable to use later, then you probably should use the return statement, especially, or actually only if you were working in a function or method. If you just want to break out of the while loop and continue on with the rest of the code and just leave it behind, then the break statement will work just fine. If there are instances where you need to restart the while loop, then the continue statement will work just fine as well. All in all, be mindful on what your project needs and be sure to choose the correct statement for your while loops. Other than that, that is all I have for this segment. Alright guys, now we are going to be getting into some of the more fun things in my opinion. And that is reading and writing to files using Python. Now, Python has a built-in function called the open function, and we pass in a file path to open a file in our script. And we can do things such as read and write We can open it in different modes to specify what we're going to be doing in the file. And it's very useful when we want to manipulate certain files in our Python program. So let's say I want to create a text file in my directory, the same directory where the Python file is housed. And we can call this myfile.txt. And there's nothing in it, but we're going to put in hello world. And we're just going to close that out. And I'm actually going to open it on this side here. So this is my Python script, and this is my text file. And I did that by taking this here, taking the tab, and dragging it on the right side of my screen. So if you're using Visual Studios like I am, that's how you can have multiple files opened up and displayed at the same time. So to open a file in Python, it is as simple as creating a variable, and we can call this my text file, and we can set it equal to open, and then we're going to type in a string, and inside the string it's going to be the file path of our file. So for me, my file is located in the same directory as my Py file. So all I really have to do is just type in my file.txt. Excuse me. And we need to open it up in a certain mode. And this all really depends on what we're going to be doing to our file. Are we going to be reading from our file? Are we going to be writing to our file? Are we going to be appending to our file? There's a lot of different things we can do to our file that we're opening up. So it is important to think about why we're opening this file and what we're going to be doing with it before specifying the mode that this file is going to be opened up in. Now, there are a lot of modes. And I mean, there are a heaping amount of modes. The ones we're going to look at in this section or segment is the R for reading mode, W for writing mode, and A for appending mode. That's the three we're going to be mainly talking about. But as you can see, there are hundreds, and feel free to investigate on what each of these do yourself. There is a documentation on Python's website that shows what all of these do. Let's first open our file in reading mode. Now, when I type in my text underscore file, we get a lot of functions that we can use. The one we're going to be using, because we opened it in reading mode, is the .read method. And we can go ahead and run this code, and nothing happens. Well, what we can do is we can type in content and set it equal to that. And then we can print out content. And then we get hello world printed out to the output, because hello world is our content, our text content inside of this text file. Now, if I wanted to add another line and say, my name is John Doe, and I am 27 years old, and I were to run this code again, you're going to notice it's going to print out all of these, and it's going to print out in a single string. Now, notice how this string is formatted. It's not formatted in a single line. This is because it is returning a doc string where we have new lines and line breaks inside of it. Now, you're probably wondering, how do we make a line break inside of a string? Well, I know I didn't really cover this in the beginning of my course, but something you probably should know is to create a new line in a string. We're going to type in something like hello for an example. And then we're going to type in a backslash and n. And then we could finish out what we want to type next. This backslash n, this is known as an escape key. And we can use it to essentially write where a new line or a space is going to be. There is a /t for an example, or there is a /r for, I believe it's a carriage break, but we mainly see /n for new line. And if I were to print this out, you'll see that it shows as formatted in 2 lines inside of my code here. If I wanted to move this right there, as you can see, world is cut in basically half. So that's how you can use new line. And that's really what's happening here. It's pulling the new lines from each line in this file. And it's going to format it that way in our console when we print out content. And just to show you again, just like that. Okay, so what if I want to write to my file? Not white, but write. I can type in something like hi. Run the code, and whoa, we get an error. And this is an error we haven't seen before. This is not like your typical value error, type error, name error, even like a 0 division error. It's nothing like that. This is an IO.unsupported operation. IO for input output. Now, what does it mean when it's saying it's not writable? Well, our file is only in reading mode. To make it writable, we need to open this file in writing mode using that W symbol or that W letter that I just shown you and talked about a second ago. So now if I run this code, it works. We just overwritten my file.txt with the word hi. But notice how it removed everything in there. What if I want to add a name? Well, we could try \n and say John for an example. But wait a minute, it removed that. And if I try Jimmy, it's just going to change that to Jimmy. How can I actually add a list of names into this text file? Well, we would have to open it in appending mode with the A letter. And now we can append or write multiple different pieces of content to the file without overwriting what's already there. So if I had something like that and I try to type in content is equal to, or actually I don't even need to define a variable here. My text file.write hello or hello, like that. As you can see, it's going to add that extra bit of content to what's already there. Now it's adding it to this next line. So if I had something like Jimmy and I wanted to type in Doe, or actually let's do Bob. Now it's going to add Bob, and if I wanted to add John, it's going to add John. So now we have Jimmy, Bob, John. What a wonderful name. But there's a problem with that. It's going to be really hard to read. And when I want to read every line inside of the text file, it's only going to return this one line, and it's going to have all the names. But we're not going to be able to parse every single name and put it inside of a list. We're not going to be able to pull every single name out like that. So what we can do is we can now actually add in a new line. And we can go ahead and run the code. We get John. Now, ideally, this works better if you already have one name in there. So if I have like Jimmy for an example, I can add John. And if I wanted to add Bob, I can type that in. We get Bob. Let's do Bobby. And then new line Jones. Let's fix that. There we go. And now all of those names are being added. So it's always a good idea to go ahead and have something in place of line 1 here. Otherwise, if you don't, when you write the first name in, you're going to get this line 1 as blank. And well, we could fix that. And I'm actually going to use a for loop here. And let's say I have a list of names and set it equal to John, Bobby, Jimmy, Ryan, Sally. Okay, 5 names is enough. And I wanted to loop through each of these names and add them to the file. Well, I can come up here, type in file equals open my file.txt, open it in A mode or in pending mode, and for name in names, file.write f string new line name. But what we're gonna do up here, is we're gonna type in file.write names at index position 0. And what we're gonna do is we're gonna type in if name.index and we are going to type in name 0. We're gonna pass and else file.write. Now, if I did this correctly, this should go ahead and add the first name John in here to fill in that line 1. And then it's going to iterate through the list and it's going to skip line 1 using the pass statement, or pass keyword, I should say. And it's going to write the rest. Let's go ahead and run it. Okay, so for some reason, it didn't go ahead and run through the rest. So, okay, maybe there's a better way we can do this. So, for I name in enumerate names, if I equals 0, pass, else, and then write. So let's remove that. Whoops. Terminate the code. And check it out. That worked perfectly. That couldn't have went any better. So forgive me, I was actually wrong on how to do this. So if we wanted to iterate through a loop of names and add all of our names to this file, we could just open our file, of course, and write the first name using the index position, which is going to be 0 for John. Add John manually, and then loop through the last 4 names by having a conditional here, checking if I is equal to 0, I being the index, and if it is, then we're going to pass it, so we're going to ignore that, and then we're just going to continue on and writing the name if the index position is not 0. Now, of course, there's most likely a better way of going about this, but this is a cool way on how we can add a list of names. And let's say I want to add another name, and this one will be Andrew. Okay, we added Andrew to our list of names. But if I go ahead and run this again, it's going to add those people a second time. And remember, we stopped at Sally, but then we just added our newest member of the Cool Club, and that's Andrew. He's a new member of the Cool Club. So I want to add Andrew to this file of names here. What I can do is I can go ahead and inside this else statement, I can type in if name in file.readLines. What readLines is going to do is it's going to return a list of all the content of each line on this file. So basically, if I run this, it's going to return this list here pretty much. And if it is, then we are going to pass, and else we are going to indent this line right here. So we just added an extra check, and it's going to check if the name is already in this file, and if it is, then we're going to pass, and if it's not, then we're going to write the name. So now, if I go ahead and run this code, it's going to, or wait a minute, whoops. Let's remove that. So if I go ahead and run this code, and it looks like it's not readable. Okay, so that should be R plus A. That should work. And one of create, read, write, and append mode. All right, let's see if RA works. Let's try W plus. And okay, so W plus actually worked. And I should add John back. So if I wanted to indent here, I'm gonna clear this out. And we're gonna add another one. We're gonna call him what's a name we can use? Nate. Why not? Run the code. It's gonna add Nate. Now, as to why it is adding or removing John, I'm not sure. But if you guys want to help me and figure that out in the comments section of this video, go right ahead. But this is pretty cool. We can basically iterate through a list of names and append them to our file if we wanted to. Now, let's say I want to get the list of names, or I want to get all the lines of code in this file. Or maybe it's not code, maybe it's just a list of names. Well, that's simple. File equals open my file.txt, open it in reading mode. Names is equal to file.readLines, print names. It's going to print out that list. And what we can do is we can type in for name in names, print names, so we can print out every single person's name. And we get these weird new lines here. So let's fix that. We can add in a dot strip at the end. Or actually, wait a minute. Name.strip, wrong spot. And what that dot strip is going to do is it's going to remove all those new line instances. And now we have our names formatted neatly with no space in between them. Pretty neat. Now, here's something that you guys should definitely know. Whenever we are done reading or writing through a file, it is always good practice to close the file after you're done. Now, why is that? Well, it is to prevent any possible corruption to your file. Now, you should do this with any file, whether it's a text file, a JSON file, especially a database file. Anything that holds data that you do not want to get messed up or lost, you should definitely consider using a close method for that file. Now, there's a certain way we can open our file without having to use that .close method, and that's opening our file within a with statement, which can be done by typing in with open my file.txt, and we can label it as F or as file. And I want to change that to read mode. Add a colon, and inside here, in this indented block, is going to be all the file read or write or append operations that we're going to be doing. So, you could type in something like, let's do an A. So, file.write, and I want to add a new name here. Let's do Jackson. Run the code, and it's gonna run. Well, I meant to do a new line there, so let's actually fix that. Forgive me, guys, I'm very tired. But now we have Jackson in our list of names on this text file. And a cool thing is that with a with open block here, with a with open as file block, we can go ahead and do all of our file operations, whether it's reading, writing, appending, etc. And we don't have to type in file.close. You do not have to do this. Now, you can if you want to get used to the habit, but it's honestly redundant when using a with block. So, if you don't want to have to type in that extra line, use a with block. But keep in mind, if you're just doing like one single operation, it's better to just type in open and then file.close after you're done. A with block is honestly, in my opinion, a lot better if you're doing multiple operations at a time. But that'll be all for this segment. Alright guys, let's go over importing and pip installing packages, modules, and libraries in Python. Now, importing packages is a key and crucial part of programming in general. It allows us to have access to more tools for our programming needs. Whether this is mathematical tools, a typing tool, by typing, I mean data types, whether it's to deal with databases, JSON data, formatting, tools for functions. There's a lot of different packages that we will definitely need at some point in our programming career. Or if you're just doing this as something to learn, it's definitely something that you're going to need with your projects. Now, how do we import something? Well, it's simple. We just type in import and then the name of the package we want to import. Now, if we want to use math in Python, we will just type in math, and my IDE automatically fills. And then, if I wanted to get the sine of an angle, for an example, I can type in angle is equal to 1.57, which I believe is the approximate of pi over 2 radians. And if I wanted to print the sine of that angle, I can type in print math.sine and an angle. And I believe it should be 1 because I think that evaluates to be 90 degrees. And yeah, so basically 1. And that's what we can do. We can import packages and then use the functions from those packages. Now, if we have our own package we want to import, what we can do is, let's say we have another Python file, so my package.py, and let's say we want to import everything from math. And which, by the way, I'm going to show you, we can actually import everything from math, or we don't have to type in math. So before, if we just import math, to get the function from math, we can't just type in sin. We have to type in math.sin. But what we can do is we can type in from math import sin, and then we can just use sin directly like that. Or if you want to do that to everything, we can type in import asterisk, which is importing everything from math. And we can type in sin, cos, tan, cosh, or cosh, sin h, tan h, log, square root, etc. And you can do this with any package too. So I'm going to leave this line in here because it's going to import everything into this file. And then what I can do, I can go back to my main file and I can type in import my package. And now I can type in my package.syn. And this is just inheriting the math package that Python adds. But I'm just doing that to show you an example how we can create our own files and import things from those files for our Python project. And also, I apologize for hitting my microphone. But that's how we can import projects or files, packages, whatever you need to our Python file. Now let's talk about third-party modules, third-party libraries. We can install those using the pip command in our command prompt. So if I wanted to type in command prompt, or type in Windows plus the R key on your keyboard and type in CMD, hit enter, you'll get a screen that looks like this. We could first start by typing in pip, and we're going to get a list of commands. Install, download, uninstall. We're mainly going to be looking at install and uninstall. That's the two commands you're going to likely use ever. So let's say we want to install a library, and let's say we want to install pandas. Now pandas is a data science and I think a graphing library, so that's just an example. But let's say I want to type in pip install and then pandas. Now it's going to give you this little screen. It looks kind of neat, and it's just going to install that package. And it usually takes a minute. Depending on the package size, it can take a while. As you can see, it's nowhere near done. And now it's done. Now, if I were to close out Visual Studio's code and open it back up again to refresh my compiler and IDE, I can now import pandas into this project. And I can use whatever the functions that come with pandas. Read CSV, offsets, concat, timestamp, API array, arrays, whatever it is, we can now use those things that came from that third-party package. And this is usually stored online. So if I go ahead and open my browser, we can go to PyP, which is the Python package index. And then we can search projects to pip install. Now I have my own called Paramath. And basically what this project of mine does is I honestly made it to help me with algorithms, but I actually made it a package that people can install. So PyP gives you a command when you go on their website to view a project, gives you a command that you can copy and paste and pip install to your Python projects. Now, I already have it, which is why I'm getting this message. But what if I want to uninstall it? Well, we can type in pip uninstall paramath. And then it's going to ask you yes or no with Y or N. You can type in Y to uninstall or type in N to not uninstall, and it will uninstall just like that. And now, if I were to try to import paramath, it's not found. Well, it thinks it's found, but if I were to refresh this, it will not show up. So that's pretty neat. And there's all kinds of projects on here. If I just go to pyp.org, as you see, there's over 6 million releases of different projects, over 500,000 projects, packages, modules, and libraries that we can install from. A common one you've guys seen me install on this channel was NumPy, custom to Kinter, Discord for my Discord series, and I believe a few more that I can't think of. But there's a lot of packages that you're probably going to have to install to further progress in your Python development. So definitely give some of these packages a try. Try to pip install some things so that way you can use them in your Python projects. But that is it for this segment, and we can move on to the next. Alrighty guys, in this segment we are going to be learning how we can store and save data using JSON in Python. Now in our previous two segments we have learned how to import a package into our Python project. We've also learned how to open, read, and write to files in Python as well. With this knowledge we can apply it to saving and reading data from a JSON file in Python. But before we get started with the code, let's talk about what JSON is and what we can use it for. So JSON is a file type made to store dictionaries or associative arrays. Now, JSON stands for JavaScript Object Notation, but despite its name, it can be used in any programming or scripting language. Now, what do we use it for? Well, we can use JSON to store some variables and values, which will be read from that file and loaded into our project, our main programming file, which in our case would be our main.py file. Now, of course, this isn't exclusive to Python or isn't exclusive to JavaScript, again, despite its name. We use JSON in just about any project, whether it is a C# project, a web development project, a Java project, a C++ project, whatever it is, we can use JSON to house some important data that we might want to use. A good example of this is if we're making a application to be installed locally on your computer, we can use a JSON file to store important user data, or not user data, but setting data. So that could be like a theme or a font size, any important settings that will configure how a program looks or works. It could also be something on a hardware level, such as memory allocation or CPU allocation. We can use JSON to store all kinds of variables and their values to later load whenever we execute a program. So the first thing we're going to do in our Python file is we're going to import the JSON library, because to incorporate JSON functionality into our Python file, we need to first import the library called JSON, which is just JSON. Now, this comes pre-installed with Python, so in this segment, we are not going to pip install anything to our Python environment. We just need to import JSON. That is all we are doing. After that, we need to actually have a JSON file to work with. So in our directory, we can go ahead and create a new file, and we can just call it data.json. And I'm actually going to open this up to the side here, just so we can pay attention to it later. But to actually open a JSON file and load its contents, what we can do is we can type in with open, and then we're going to pass in the path of our JSON file as a string. And now the JSON file's housed in the same folder as my Python file, so I just need to type in data.json. And we're going to open this in reading mode. And we can call this file JSON file. Now, to actually load the data into our Python file, we're going to create a variable, and we can call this JSON data. And we're going to set it equal to json.load, and then we're going to pass in our JSON file, which is this right here. So what this load method from the JSON library is going to do is it's going to pull everything out of this JSON file, and it's going to store it into this JSON data variable as a dictionary. Now, if you've seen the structure of a JSON file before, it looks exactly like a dictionary in Python or an associative array in any other programming or scripting language. So there is no difference in structure, and there's one minor difference with syntax, and that's that in the last key or any last variable in a JSON file, you do not include a comma, otherwise it is not properly formatted and will throw you a syntax error. But in the way that we retrieve data and treat it in Python, it works the exact same way. Now I have this here to actually load data from our JSON file, but we haven't had anything in it yet. So instead of having that, let's change this file or this with open statement to open the file in writing mode. And up here, I'm going to create a variable called data. Or actually, just for the context, let's call this JSON data. We're going to set it equal to a dictionary. And we can give a key called name. And we're going to set it equal to John Doe, for an example. And then we're going to add another key called age, and we're going to set him to be 29 years old. And then lastly, for gender, we're going to make him a male. Now, we have this little dictionary called JSON data. So, how do I actually add it to my file? Well, you could just copy and paste it just like that, and remove this variable declaration here and leave it like this, and it'll work just fine. But there's no fun in that. Well, it works, but we want to learn how to do it in Python, so that way eventually we can automate this appending of data to our JSON file. So, inside our with open statement, which is now opening in writing mode, keep in mind, we can go ahead and type in json.dump. Dump means to store data or dump data into the file. And then we're going to pass in the JSON data. Then we're going to pass in the file we want to dump this data into, which is JSON file. And then we want to specify an indentation. Now this is completely optional. You don't have to specify an indentation. If you don't, what's going to happen is everything's going to be stored in a single line. Now this can be pretty hard to read, so ideally you want to set an indentation level to be 4, so that way it can be readable, much like how this is right here. So we're basically done. If I go ahead and run this code, you'll notice it went ahead and automatically added that data into this JSON file. Now, what if I want to change the name? Instead of John Doe, let's say he's a Jimmy Doe now. And instead of 29 years old, he's actually 32. Well, I can go ahead and run this code again, and it's going to actually overwrite the name and age keys inside of this JSON file. Now, what if I want to change just one thing, one key inside this? I don't want to have to specify JSON data and predefine it with the keys that's here. What if I want to first read the keys and then create a variable to load all of that data into a dictionary, like how we discussed when we first opened our JSON file in reading mode? What if I want to do that and then change some keys and then add some extra variables or edit some variables in that sense? Well, what we can do is we can go ahead and remove all this, and we can actually go ahead and type in with open it in reading mode as JSON file. JSON data is equal to json.load JSON file. Now, keep in mind, whenever we're loading data from a JSON file into a variable like JSON data, for an example, we are storing it in this variable as a dictionary. So if we have a regular predefined dictionary in Python, it's the same syntax, it's the same way that we will access data from a JSON file. It's the same way we would do it from a regular dictionary. So, remember, back to my collection segment towards the beginning of the course, we have talked about how we can take our dictionary called, let's say, data, and then we can specify the key by typing in the key's name right here, and then we can go ahead and get the value from that dictionary specified at that key. So remember, I would say I had a value, and I set it equal to dictionary, and then key 1. Well, then this would actually get me the value from key 1 and stored inside this value variable. So that's how we would pull values from keys. Well, it's the same way with JSON data. And I know I kind of over explained it a bit, but this somewhat kind of confuses people just because it is so similar in Python. But if you've had experience in other programming languages, the way you would go about this is a lot different. So this has brought up some confusion in the past, and I just want to be very clear that it is the exact same way as you would pull data from a dictionary. So let's say I just want to print the person's name from this JSON file. Well, we're going to type in JSON data, and then I'm going to print the name keys value. And I'm actually going to open this in my file explorer and then my command prompt, so that way you guys could see this just a tad bit better. Python .py. And as you can see, we get Jimmy Doe in the output. So that's just to prove to you that we're working with this the same way we work with a dictionary. But back to our main objective. What if we want to change one of these keys without having to predefine another dictionary and then just overwrite the entire file? Because that's basically what we were doing. Well, we can easily just type in JSON data name, and let's say we want to make Jimmy Doe now be Sally Doe. And obviously Sally Doe's a woman, so we are going to set the gender to female. Well, now we're just reassigning the values for those keys, because remember, a dictionary is mutable, just like a list is mutable. If we were accessing a list or a list element at a certain index position and then reassigning the value there. Works the same way in a dictionary, except instead of an index position, we are dealing with a key. And, well, we can just reassign the values like this, and then to actually store that new data in here, we're going to type in with open data.json in writing mode, denoted by the letter W. Then in here, we're just going to type in json.dump, JSON data, JSON file, and the indentation is going to be 4. Now, pay attention to the JSON file when I go ahead and run the code. And as you can see, it's overwritten just these two singular names, or these two singular keys and or variables, whatever you want to really call them. But it left age alone because we didn't go ahead and actually change the age variable or the age key. We just configured these two right here, and so it only written or overwritten these two. Whereas before, when we had all of this data predefined in our Python file and then having it stored that way, it was actually just removing this and then putting it back with the new values. So technically, even though the age wasn't being changed, it was still being overwritten. And well, that's not necessary. In some instances, it can take up some more resources or even cause your file to possibly be corrupted. So we only want to change or reassign values to the necessary keys that we are actually changing. We don't want to technically overwrite a value that's just going to stay the same. Now, we could also increment values inside of our JSON data. So if I typed in JSON data, for an example, age, and I could type in +=1, because let's say it is Sally's birthday today. Well, if I go ahead and run this code, as you can see, that 32 now changes into a 33. Now, There are a lot of different things we can do with JSON files. We could use them to store settings values, like I stated before, such as like a theme, a font color, or even maybe a font itself. Or we could also store some basic configuration settings for maybe how much of your computer's resources in terms of hardware that it's using or going to use. There's a lot we can use with JSON files. Now, if you have been watching my Discord bot series, my first edition back in 2022 and 23, you may remember that we've used JSON a lot to store things such as server or guild prefixes, leveling, role, and user IDs, stuff like that. You can do that with JSON. That's what I used in that series. But ideally, whenever you want to store a lot of data, data that you don't want to be messed up, especially, ideally you would want to use a database. But if you ever need a quick way to store and save data that's just dealing with like a few variables at most, JSON will work just fine for you. It all really depends on the project you are using. Now, there is a better way to store more data that needs to be secured, such as maybe an authentication key or an API key, some sort of password or a number, whatever information you don't want people to see. Well, we can actually use a special type of file called a .env, but we will see that later towards the end of this course. But that is it for the JSON section or segment, and I hope you guys enjoyed, and I will see you on the next one. Alrighty guys, in this segment we are going to be learning how to handle errors in Python. Let's say you are working on a project that just keeps running into this error and crashing your code, and you're not sure how to mitigate around it, or essentially just dismiss the error as a whole. Well, there is a process in programming called error handling, and in Python we have some keywords used to handle errors known as try and except. Now, in other programming or scripting languages, you may be familiar with the terms try and catch if you've programmed in something like C# or Java. In Python, essentially what the try keyword does is it will tell the program to try and execute this code. And with the except block paired with the try block, the except block will be there in case of an error happens to be occurring. And usually what the except block will do is it will execute certain lines or blocks of code based on the occurrence of that error. So a perfect example for this, which is a solution I'm going to show you guys later on in this segment, but a perfect example of this is, let's say we're designing a calculator, and we all know about the zero division error. It does not make sense. We cannot divide by zero. Well, if I try to define two variables here, and I try to define a new one, and let's say z is equal to x divided by y. As you know, y is 0, and we can't divide by 0. Well, if I run this, it gets an error in our output log, or our console. And it says 0 division error, and then it gives us a short description, division by 0. Obviously, that's a problem. That just crashed our entire program. And well, if you're designing something pretty hefty, you don't want a simple error like that to just crash the program. Maybe you want that to just output into the console, hey, you cannot divide by 0, and then move on to the rest of the code. Maybe that's something you want to go for, and well, typically that's the best way to handle an error like that. So we're going to use a process called error handling in Python, and there are 3 keywords to keep track of: the try, except, and finally blocks. The try block will try to execute the relative lines or blocks of code, while the accept block will be there to watch for an error, and if that error occurs, then it will execute some lines or blocks of code. Now we have finally. Now, this is an optional thing you can implement. You do not have to have it in your code, but it is used to execute code after try and accept. So for an example, if I have try and we have some code right here, and I have an accept block, and this is going to be the code that will run if an error occurs. I can implement a finally block. And basically what will happen is, when I run this program, it'll run all of the code inside the try block. And let's say for this case, there is no error. So it'll skip this entire accept block and it will run the code inside the finally block. But let's say the second time around, I run this program and the code inside my try block runs to an error. So it activates this accept block and runs the code. What the finally block will do is it'll go ahead and run the code no matter if there is an error or not. So if you use this finally block, which by the way, I should add that it's quite uncommon to use it now, but if you do use the finally block, essentially it's just going to run code no matter if there's an error. Now, where might you use this? Typically, it's in a program that deals with a file, or maybe a network connection, or a database connection. This is where you would use finally a lot. Let's say in my try code here, I have an open or a with open statement, and I have some file operations. But let's say the file doesn't exist. Well, this will trigger an error called file not found error, and then I'll have it run this code here. So maybe I don't want that file to try and open anymore if this happens to be in a loop or something. So this finally block will close that file. A better example is if we are opening something on a network, whether it's a database or anything really, and we have some database operations and an error occurs. Well, it'll execute this accept block here, but after that error occurs, we want our database to be closed so we don't have any more future errors later. Well, that's what we will do in this finally block. We would type in something like database connection.close for an example. Now, I show this a bit more on my databases in Python tutorial, which you guys can watch if you would like. It is very simple and it's not too complex as well if you are a beginner in the language. But these are just some examples on how we can use try and accept. So let's go ahead and use this in action. So let's say I have a while loop, or specifically a while true loop. I'm going to create a print statement here and then some inputs. Welcome to the division calculator. And we are going to now type in float, or I'm sorry, wait a minute, x is equal to float input, enter value for x. Equals float input, enter value for y. Then it's going to type in try z is equal to x divided by y. I'm going to add some space there. And it's going to print z. Then accept 0 division error, print cannot divide by 0. And for the try block, we want to break if everything is good, and then we want to type in print thank you for using the division calculator. So, I know I kind of jumbled up a bit there. I am a bit sick, so forgive me for that. But, so far we have a while true loop. And inside this while true loop, we have welcome to the division calculator. And we have two inputs, x and y, are set to take in as floats. And we have our try block here, which is setting z equal to x divided by y. And then we have it to print z, and then we have it break out of the while loop, so we will see this message right here. And then, in our accept 0 division error block, we have it print cannot divide by 0. And what we can also do here is we can type in continue, so it'll restart the while loop. Rather than breaking out of the while loop and then printing this message and then exiting the code normally. So I'm going to go to my file explorer, open a command prompt, python main.py. Now, so excuse my allergies, but now over here, you see my code again. Enter value for x, let's do 12. Value for y, let's do 6. And we get 2.0. So that works perfectly. Now let's try to divide by 0. 12, 0. And now we get a cannot divide by 0 error. And you may notice, instead of getting the thank you message at the end, we actually get a welcome to the division calculator message again. So it restarted this while loop due to this continue statement that we learned about earlier. And then we can go ahead and try it again. And this time I'm going to divide by 4 just to show that the code will now exit, in which it did. And we know it did by getting this little command prompt message right here in our terminal. So that's how we could use try and accept. Now, let's just throw in a finally, because why not? Finally, and then we can print, woohoo, I reached the end of the while loop. And I'm going to bring that back up. Well, 0, just to show that it's going to trigger an error through that accept block. Cannot divide by 0, and even though we hit an error, it went ahead and ran this finally block, which executed the code to print the message, woohoo, I reached the end of the while loop. So pretty simple. That's how we can use try and accept in our Python projects. Now we can go ahead and move on to the next segment. Alright guys, welcome to the basics of object-oriented programming in Python. Now this segment of the course is going to be probably the more complex segment than some of my others, and it's going to show us how we can create objects and use them in any of our Python projects. Now, just a few of the things we'll be going over is the creation and initialization of an object, object attributes, or otherwise formerly known as properties, public and private properties, some methods, and as well as how we can iterate through a list of objects too. So that is some of the things we are going to be going over inside of this segment. So there's some of the bare basic stuff. Now there's obviously a lot more you can do with objects in Python, but not really, it's not really feasible to include everything in this course, especially that this course is more designed for beginners. But with that out of the way, let's go ahead and get started. So to create an object, we start with the class keyword. And then we can give our object a name. So what makes a good object? Well, perhaps maybe you are developing a game and you have many different characters, such as the player, the enemy, or possibly just a bunch of NPCs. Well, all of these characters are unique from each other. They have unique appearances, names, perhaps max HPs, damage ranges. All these properties or attributes of each character are different. So we would create an object called a character, and then we would define all of those properties for each character. So in this example, we're going to be doing something similar, but we're going to be dealing with a object called person. And this person's going to have a name, an age, and a gender, just like how we've been dealing with previously in this course. So the first thing we're going to do is we're going to type in def dunder init dunder. Dunder means double underscore, by the way. And then we're going to type in self, and then the name, age, and gender. And I am trying not to type everything that comes out of my mouth, like that little and I written out there. Now, what is this method called? This is called the constructor method, and it basically, well, constructs our object. It gives our object a unique name, age, and gender. And if we want to, we can type in these. So the name is going to be string, age is going to be integer, and I swear I typed in a colon there, but that's fixed. And then gender is going to be a string again. And in here, we need to define each of these properties. And we do this by typing in self.name is equal to name, self.age is equal to age, and self.gender is equal to gender. Now, if you've programmed in other languages like C# for an example, you may notice that this is just like this.gender or this.age. Self works the exact same way. It really is the exact same thing, just a different name, in case you may have noticed that, or if you were possibly wondering. Now, something to keep in mind with Python is that every property you have here, Python assumes that it's a public property. Meaning, if I wanted to, I could type in something like person1 is equal to person, and I can type in John for the name, 29 for the age, and male for the gender. And I can go ahead and access John or person1's name outside of the class. If it is a public attribute or public property, we can access the name. It is mutable, meaning we can change it. So instead of John, he's now going to be Andrew. We can basically just work with the name property of person1 outside of that class. That is known as a public property. Or, well, at the very basic level of a public property. We can use it outside or inside of this class. To make a private property, we're using a double underscore before the property declaration. So self.double underscore or dunder name is equal to name. Now, if I try to type in something like .dunder name, let me fix that. Instead of equal to like Andrew or something, if I were to run this, works perfectly. But what if I try to print it out? Print person1 dot dunder name. We get an error. We get an attribute error. And it says it has no attribute. We can't access it outside of this class. But if I were to just remove that, and remove that, run it one more time, we get John in the output. So that's basically how public and private attributes or properties work. Now, there is a way we could still access private properties. And for now, I'm going to put in a comment here. Whoops. Public. And public again. So age and gender are public, name is private. So keep that in mind. Now, if I want to be able to access name outside the class or maybe change what name is, even though that's private, what I can do is I could type in at property. This is known as a at decorator or a decorator in Python. And this is the more quote unquote Pythonic way of setting or getting a getter and setter put together for an object. There are other ways you can do this in languages. I know C# uses like a public string and then the name of the property, and then you have your getter and setter inside of it. This is just a Python way of doing it. But we can type in at property, and we're going to define a new property called name. We're going to pass in self here so we can access this self._name. And then we are going to type in return self.dunder_name. So now if I create a person1 here, John, 29, and male, and go ahead and type in print person1.name. And we get this little star here if you're using Visual Studio's code. That shows that's a property. And well, it actually tells us that's a property up here. And if I go ahead and run this, we get John back in our output. Now, how do I change a private property? Well, let's remove this print statement real quick. I can come back inside this class, type in at name.setter, def name again, self, and then new name. And then we can type in self.dunder_name is equal to new name. Now, we tried to do that. We tried to use .dunder_name and then set it equal to whatever we want to set it equal to outside of the class, but it didn't work. It said that the attribute didn't exist. Well, that's because it's private. But since we're inside the class, we can go ahead and use dunder_name freely now. So now if I go ahead and type in person1.name and set it equal to Jimmy, what I can do now is I can type in person1, actually no, print person1.name. Run the code. And now we get Jimmy on the output, even though we have defined person1 to have the name John. So we have created a getter and setter for the name attribute. And of course, you would do the same for age by just typing in that, and then dunder age, and we just need to privatize age as well. And new age. And let's change this to age.setter. And let's do something here where let's do a check. If new age is less than or equal to self.dunderAge, and this is basically checking if we're putting an age less than the current age or same as the current age, then we're going to type in print age cannot be the same or less than the current age. And if not, then we're just going to type in self.dunderAge is equal to new age. And now we have 29 here, but let's say he is now going to be 30 years old. If I go ahead and run this, and it looks like age of person object has no setter. That's weird. What do you mean? Oh, okay. I forgot to change that name there to age. That's my fault, guys. But as you can see, he's predefined to be 29 years old, but then we set his age to 30 because today, on October 3rd of 2024, it is his birthday. So let's go ahead and run this code. And woohoo, we now get 30 in the output. So that's how we can use getters and setters inside a object. Now let's get out of the getters and setters, and I'm going to make these public again. And we're going to create a few objects here. Let's say person 1 is equal to person. And John 29 male. Person 2 is equal to person. Andrew 24 and male. And then person 3 is equal to person. Sally 32 and female. I know I use these names repeatedly all the time. I need to get original, but it's very simple. We have 3 people here. So let's create a list, people. And it's going to be type hinted to be list type object is equal to person 1, person 2, person 3 inside of a list. Now we can type in for person in people. We can now type in print name and let's actually do this as an F string. Person dot name. And I don't think there's actually a way we can type it. Actually, let's see. Okay, yeah. Figured so. We can't type int it that way. So, your IDE is not going to be smart enough to actually know that this person here is reference to this object. Unless, let's actually... Okay, I was wrong. So we can type int it. Change that from object to person, and then it knows exactly what you're talking about. And now person, and then it's type object person. Sweet. So let's do this. Or whoops. Person dot age, person dot gender. And now we're gonna print. And we're just gonna make a line just to separate everything. And I'm also going to do the same thing up here. So now we're going to iterate through these 3 people, this list of 3 people or 3 objects in terms of Python. I know that sounds horrible saying it out loud, but that's technically what these are. And look at that. Name John, 29 male, Andrew, 24 male, Sally, 32 female. So now you know that we can work through each of these objects, we can iterate through them, and perhaps we can add in some checks. Maybe we're looking for the person's age to be over 18, and then we could maybe put them in a separate list called adults. Or if they were under 18, we could put them in a separate list called minors or non-adults. We could maybe separate some of these people based on the first letter of their name, their age, their gender. We can do all kinds of different things with these person objects now by iterating through them. So let's say we want to separate people that are under 30. So that would leave Sally out of that list. So let's type in if person.age is less than 30. Then we can go ahead and run this code. Or whoops. Let's try it again. Okay, so now with this little if statement here, we left out Sally from that list. We've only included John and Andrew because they are under 30 years old. And of course, if I type in 20 and run the code again, It's not going to put any of them in because none of them are under 20 years old. But if I do something like 40 or whatever the oldest person in our list is, it's going to include all three of them again. So that's pretty nice. We could separate objects based on certain properties. And, well, in this case, age, or maybe the first letter of their name, or gender, or perhaps if we made a more complex person object, we can include things like occupation, or we can include things like email, we can include things like maybe hair color or eye color. We can include a lot of different things if we're dealing with an object in the context of a person. But maybe, just maybe, if you're developing a game, we can have things happen with objects of characters that maybe have over 100 HP. So maybe we have a boss enemy somewhere, and well, we want our code to run differently based on that HP being over 100. To kind of show, okay, we have a stronger enemy here. That's a very vague example, but it shows how we can have uniqueness in each of our objects. It shows how each of our objects is very personal or customizable. And we only have one class called person here, but we have 3 person objects. So we're using this base class called person to create 3 different people. And then we can iterate through those people and list out their names, their ages, genders. We could sort them by ages, names, whatever you really want to do with each of those people. This is just how we can do it. But that is basically it for object-oriented programming, and I will see you guys in the next segment. Alrighty guys, in this segment we are going to be learning some of the basics of the OS module in Python. Now, the OS module in Python provides support for some basic OS operations for your computer, whether you are working with Windows 10 or 11, any version of Mac OS, Linux, whatever OS you have, Python has a module to where you can use some basic functionality for your projects. Typically, we use the OS module a lot whenever we want to clear a console, or whenever we want to perhaps go through a list of files, iterate through a folder, maybe do something with files, creating files, and we can also pair it with opening, reading, and writing to files as well. If we ever maybe want to create a crash log for a game that we're making, or maybe we want to just list some files, and if they're text files, we can read them. Or maybe if you're designing a audio player, and on the side you have a list of all the songs, their file name and such, we can use the OS module to iterate through that folder of songs and play the ones based on their file extension. Maybe we only want to allow MP3 files and such. So there's a lot of different things we can do with the OS module. Typically, we're going to be working with a lot of files and file paths and folders. So to get started, we are going to import OS. And let's say I have a file path here. And just in case you're curious, this is my file path to this Python course. I have a folder storing all these segments to this course inside this path here. Now, let's also say I want to iterate through that folder and list all the files that exist. Well, what I can do is I can type in directory, or actually first I can type in path and set it equal to the string of my full path to the Python video folder. And then I can go ahead and type in directory is equal to os dot list dir. Dir is short for directory, so os dot list directory, and then I would pass in that path. And then I could print directory, which would print out a list of all the files, because this list directory is going to provide me a list of type string, a list of all the files inside that folder, Python video. So essentially, if we just go down here to my Python video folder, as you can see, it's going to list all these files' names and extensions. So that is the expected output. But if we go ahead and run this, Python main.py, we get a syntax error. Why? So it says it's a Unicode error, specifically a Unicode error. And it says Unicode escape. Codeg can't decode bytes in position 2 to 3, truncated at \uxxxxx escape. So there's a problem with the string. It cannot read the string. Well, if we look at our string, look closely, we can see there's an area that's highlighted. And the problem is occurring right here. Essentially, what this is called is a tab. And we can create these little string formats by using the backslash and something like tab, or T for tab, N for new line, R for carriage return, and stuff like that. There are some escapes here. There are some escapes. One is a double quote escape, and basically it allows for this double quotes to appear inside this string, because if I remove this, then we're going to get a syntax error there, because it thinks the string is closing right here. Now there's also R for carriage return, N for new line, T for tab. I've already discussed those with you. There's also a double backslash, which would just remove one of these in the output. But because of my name here, we get this problem here. So this might be a problem you come across in the future. Well, how can we fix it? Well, we could actually turn this string into a raw string using the R letter and placing it in front of the first quotation or indication for a string. And it's going to change the entire color of this. And what it's going to do is, this is going to tell Python, hey, this is a raw string, ignore every formatting problem or any formatting issue that could arise here. This is just going to be a raw string, so it'll just look like this, basically. If I remove it, well, then Python's going to think that this is supposed to be a tab when it's not. So putting this R here will tell Python to ignore this tab here, this tab in the string. It will ignore it. And then if I go ahead and run this again, we now get this list of all the files inside of our folder. So we have installation1.nkv. This is just all my videos and segments. I have a couple text files, and I have one MP3 file as well. So now we have a list that has printed. Well, what if I want to iterate through this list? Well, I could type in for file name in directory print file name. And I can go ahead and run this again. And now we get a list of all of our files. It's a little bit more readable, and it's top to bottom. Pretty neat. All right, well, what if I want to check, or what if I want to list all the text files, or all the files that are not a video? So I don't want the MKV files in this list. Well, there is a method we can do, and we can type in if file name dot ends with, and in here we can provide the file extension for each file. And let's say if it ends with .mkv, which is a video file, then what we're going to do is we're going to type in pass. And what this pass is going to do is it's going to essentially tell Python, okay, if this file ends with .mkv, then I want you to go ahead and do nothing. I want you to ignore it. That's essentially what this pass keyword does. It just basically tells Python to do nothing here. And you can use this in all kinds of things. You can use them in while loops, functions, conditionals, obviously, like what I'm doing. Typically, it's more used when you just want a placeholder to be there until you decide or until you start writing the code for that functionality. But we can use pass in some instances like this where we just want the MKV file to be ignored. And then else, and then print file name. And now, as you can see, we just get our notes and order.txt files and pre-intro.mp3. So all these MKV files were ignored.
It's time for bed.
Alrighty, so what if I want to clear this console? Well, let's say we have some print statements up here. Hello world. And I'm going to copy and paste this several times. And let's remove these. And then I'm going to type in input. Looks like your console is cluttered. Would you like to clear? And what we can do is we can type in if x is equal to, say, y for yes. Then we can type in os.system. And if you're on Linux or Mac OS, it's going to be clear. If Windows, then it's going to be CLS. Don't ask why it's different. I honestly don't know. But let's go ahead and run this. And we get hello world a bazillion times. And now it says, looks like your console is cluttered. Would you like to clear? Well, we can press in Y. And as you can see, this entire console is now cleared. All of the printed data is gone. And well, why would this be useful? Well, maybe you're making a console-based application and you want a clear command to remove all previous command histories and such like that. So this is pretty good. We can now actually clear our console, especially if we're making a text adventure game. Which, if you're not sure what I'm talking about, basically a text adventure game is a console-based game where you just go ahead and answer several questions, you decide, and then your story is played out based on your decisions. It's pretty cool. I plan to make a simple video on one soon in the future, but we could use this os.system method here and include CLS to clear our console. So that's pretty neat. And that's just about it for the OS module on this course. I plan to do an actual video covering just about everything in the OS module, and we are going to see it one more time when we get into .env. But that is it for this segment, and we can go ahead and move on to the next one. Alrighty guys, in this segment we are finally going to learn how to use .env in our Python projects. So, firstly, what is .env for? Well, .env is a file type that we can use to store several tokens for our project. Now, these tokens could be a token for your Discord bot, could be a token or an API key for a Reddit Pro API. It can be a password, it can be some credentials for a database or a network. Essentially, it is a file where we're going to store most of our more sensitive data. And the nice thing about .env is on GitHub, if we ever want to push our project out, we can tell GitHub to ignore the .env file, so that way when we upload our projects, that .env file is safe and nobody can access the data within it. So, to get started, we do need to pip install something. So, go to your command prompt and type in pip install python-.env. Now, I already have it installed, so I'm going to get this message right here. But for you, you're most likely going to see a message saying it's installing, and it's going to have like a little loading bar, and then eventually it'll tell you that it has successfully installed. Once you see that message, you can go ahead and close this out. And do be sure to reload your entire IDE, whether it is closing and opening it back up again, or just closing out the file and opening it again. Do whatever you can to reload your IDE, so that way you can ensure that the module is being loaded in correctly. But after we do that, we can type in import.env, and then we can go ahead and type in .env.load.env. Now, to avoid typing the entire thing out, what we can actually do is we could type in from.env import load.env. And then we can just go ahead and call .env, or I'm sorry, load.env directly, just like that. And ignore the message I'm getting. This is just because pylons can be a little weird sometimes. But after that, we can go ahead and import OS. And then we can go ahead and type in os.get env. And inside here is going to be our environment tokens. Now, first we need to create a .env file. So in the same directory, or in the same folder as your main Python file, we're going to type in .env. And then in here, we can go ahead and start defining some tokens. So let's say this is my API key. And we can set it equal to hello, I'm a API key. And we can type in something else like token. And then we can say hello, I am a token. Pretty simple. Now, inside this os.getEnv, we can go ahead and type in the token or the environment names of each of the information we want to get. So, for an example, here would be API key. And we could store this in a variable called API key. And let's just say token is going to be equal to os.getEnvironmentToken. And we can print each of these. So API key. Let's remove that. It's just tab 9 being stupid. And then we can also print token. And let me just fix that. And we get both pieces of information, whether it's a token or an API key or whatever you want to store. We get this printed in our output. Now keep in mind, I didn't even specify where this env file was. So that's because automatically load.env will search inside our main projects folder and try to find the .env file there. If you do not have that env file inside your main folder, then we need to go in here and type in .env file and set it equal to the actual file path of our .env file. But generally, it's just recommended to put your env file here to avoid any possible file path issues and such. But that is how we can use .env in our Python projects. And again, we would typically use this when we're dealing with something like sensitive data, whether it's an API key, a token, some network data, anything we want to store securely, we can do it in an .env file. So that way, when we finally push our project out to somewhere like GitHub, we could just leave the .env file out of the upload, and nobody on the internet will see it. But that is it for this segment, and we can go ahead and move on to the next one. Okay, guys, this is our last segment where we're actually learning some new Python methods and codes and all kinds of sorts and things we can do with Python. This is our last segment where we're going to cover something new before we get into our two solution segments where we kind of combine everything from this course into a simple and pretty well put together Python project. In this segment, we're going to be learning the math module. Now, the math module is a Python module that's pre-installed with Python, just like OS, just like JSON, just like quite a few modules that we can use with the base Python installation. Now, the math module offers us a lot of tools that we can use to, well, do math in our projects. Whether it's trigonometry, finding square roots, finding logarithms, all sorts of things we can do with the math module. So to get started, we are going to import math just like that. And then we can go ahead and start playing around with some of these functions. The first functions, or I should say methods that we're going to use are the floor and ceil methods. And these are essentially going to round around a given number up or down to the nearest whole number. So let's say I have a number like x and I set it equal to 3.25. And I want to have two variables. One it's rounded up and one it's rounded down. So rounded down x would be equal to math.floor, and we're going to pass in x. And rounded up x would be equal to math.ceil x. And we can go ahead and print some of these out. Well, we can print both of these out, and we're going to create a little message. So 3.25 rounded up to nearest whole number is, and then we can type in rounded up x. And we can go ahead and change this to down, and then change this to rounded down x. And if I go ahead and run this code, we get 3.25 rounded up to the nearest whole number is 4, and then rounded down to the nearest whole number is 3. So that's how we can use floor and ceil. What if I want to find the square root of a number? Well, let's say I have x equal to 9, and it's just an easy one. We know the square root of 9 is going to be 3. So I want to find the square root of 9. Well, I can type in math.sqrt, which stands for square root, pass in x, run the code, and we get 3.0 as our answer. Let's make this something more complex, where we know that it's 12, and we can confirm this with our program here that returns 12, or prints 12 to the output. Sweet. Now, let's try something a bit more complex. Let's get into some trigonometry here. So math has sine and cosine and tangent functions, as well as the hyperbolic versions of them. And we can use them to find the sine of some angles. Now, the thing about the math library is when you're dealing with angles, it assumes you are dealing with them in radians. So we can't just type in math.sin and then put 60 degrees. It has to be converted to radians before we do so, which is actually pretty nice. Let's say I want to find the sine of an angle, and I'm going to create an input here. So float input and enter angle in degrees. Then I can type in x is equal to math.radians x, and this will convert x to radians. And then I can print an f string, your sine of the angle. And to actually get it back in degrees so we can view it in the console, we're going to type in math.degrees x is math.sin x. If I go ahead and run this code, enter angle in degrees, let's do 60. Your sine of the angle, well, it's going to say 59.99999, but it's the same thing as 60 degrees. And the sine of that angle is 0.86. Let's try something that I believe 30 degrees is 1/2. Let's do 30 degrees. And what do you know? We get 1/2. Well, we get 4.499999, but that's just 1/2. We can round it up to so. And let's do one like 90 degrees. Because we know 90 degrees, or the sine of 90 degrees is going to be 1. And there we go. The sine of the angle 90 degrees is 1.0. And of course, we could do the same thing with cosine. And let's do 45. Because 45 is, I believe, 1/2. Or no, it's 0.707. Yes, 0.707. It's actually the same for sine and cosine. 45 degrees is 0.707. Let's go ahead and work with radians. What if we don't want to work with degrees? Well, the math module has a pie. It has a pie. Cherry pie, pumpkin pie. No, we're talking about the ratio of a circumference to its diameter. So, print math.pie, and what are we gonna get? Is it cherry? Vanilla? Blueberry? No, it's 3.14. Now, let's say I want to convert... Alright. So, let's say I want to convert pi over 2 to degrees. Well, we know that in radians, it goes from 0 to 2 pi. So therefore, pi should be 180 degrees if 2 pi is 360. Well, then that would mean that 90 degrees is pi over 2. So we should be able to type in print degrees, or I'm sorry, math.degrees. Then math.pi divided by 2, and we should get about 90. And we do, we get exactly 90. So pretty nice. So just like how we converted degrees to radians, we can also convert radians to degrees. And if I change this to times 2, we should get 360, in which we do. And if I just wanted to print pi, or just leave pi in there, then we're going to get 180. Now let's talk about logs. Let's say I have a number and it's going to be 0.002. Let's see, 1, 2, 3. So we should get either, the answer should be -2 or -3. I can't remember, it's been a while since I worked with logarithms, but let's try to print math.log10. The 10 means base 10, by the way. And we're going to pass in x. And, okay, looks like we'll get -2.69. Let's try that. Alright, there we go. Now we get -3.0. I forgot, we're working with base 10 here. So, that's how we could use logs. And then if we want it to be base 10 still, and we have 1 million, well, we know the log base 10 of 1 million is going to be 6 because there are 6 zeros there. And it just comes out evenly, and we get 6.0. But what if we want to get the natural logarithm of a number? What if we wanted to get x is equal to math.e times 2? Or to the power of 2, I should say. Well, we pass in x into math.log. We should get 2 in our output, because the natural logarithm of e to the power of any number will just be that number. And we get 2.0. Changes to a 3, and we get 3.0. Pretty neat. Now, there is obviously a lot more to this math module, but there's a lot of different things we can do to just get some basic or some quick calculations done for our projects. This is very good if you're designing a game and you want to involve a lot of like probability and such of that. We can use the math module for that. There's just a whole lot of things we can really do with it, and I do have a documentation on Python's official website for you to play around with more of the math functions. But that is all for this segment, and we can finally move on to our solutions. Alrighty, guys. Now we are on our first of 3 solutions for our Python course. These are just going to be 3 little mini projects that are supposed to encompass most of the things we have covered inside of this Python course. This is all, of course, going to be beginner level, and it's stuff we have already seen or stuff that's just generally pretty easy to use in Python. This first solution is going to be a very simple console-based tax calculator, where you will enter a subtotal, enter a tax rate, and then you'll get your final total of your subtotal plus your tax rate together. To get started, let's go ahead and print out a statement welcoming us to the tax calculator. Welcome to the Python tax calculator. And then we're going to create a variable and we're going to call it subtotal. And then it's going to be a float. And then input. To get started, enter in your subtotal. Then we can go ahead and type in tax rate. Tax rate, and then in percent. And actually, let's make that a little bit better. Enter tax rate in percent. Then we are gonna type in a statement. Is the following information correct? And then we're gonna type in Y and N for yes or no. And then we're gonna print out the information we've entered. Subtotal. And we're going to do the same thing for the tax rate. I keep messing this up. There we go. Now, we should really do all of this in a while loop. So while true. Let's fix that. Let's put that out there, so that way it only welcomes us one time when we open the application. Now we're going to use a conditional to check if we say Y or N inside the input. But we need to create the input itself first, so yes, no, input is equal to input. Then we can go ahead and type in if yes, no input equals Y. Then we are going to go ahead and proceed with calculating the tax and then putting that out in the console. But I'm going to write past there, and then we're going to type in else or elif yes, no input equals in. Then what we're going to do is we're going to continue, but we're going to first print, and we're going to type in restarting application. And after that, we are going to actually use a module I haven't covered in this course, but it's nothing major. We are going to type in import time in 3. Put a period here, remove that. Then we can type in time.sleep. And this is going to take in seconds, so we're going to put 1 second, and we're going to do this over and over again, just to give us a little bit of a countdown when we're going to restart the application again. And then we're going to use the continue to restart the while loop. And let me just go ahead and make this a bit more easier to read by decreasing the font size. There we go. Okay, so we have it to restart the while loop afterwards. And then else, we're going to print invalid input. And this is effectively going to crash our program just because we don't want to do anything afterwards. So we're going to use the break. And outside here, we're going to print exited application. Now let's go back to this yes and no input equaling to y. So if it is y for yes, then what we're going to do is we are going to type in tax is going to be equal to tax rate divided by 100 times subtotal. And we're going to encompass this in some parentheses, so that way we can ensure that the order of operations is being done correctly. After that, we can go ahead and type in total is equal to subtotal plus tax. And we can go ahead and print your total is... Actually, no. Let's do something a little bit better. Subtotal and let's do one for tax. Let's actually do one for tax rate and do one for the tax itself. There we go. So let's just space some of these out a bit. And let's go ahead and make the font size a tad bit smaller. Okay, so we have a basic input and output console application for a tax calculator. Let's go ahead and try to run it. Welcome to the Python tax calculator. To get started, enter in your subtotal. Let's say it's 12.99. My local tax rate is 7%. And it's going to ask if the following information is correct. Let's say yes. And now it's going to say subtotal $12.99, tax rate 7, tax 90 cents, and total is 13.8993. But there's some problems with this. One, it makes everything look extremely cluttered, and two, the math isn't really in a dollar format. So let's fix that. What we can do is we can remove this line by using Control X. We can paste it later, and then we can type in, actually, yes. Let's remove this here. Set total equal to round. And then we're going to round it to the nearest, we're going to round it to the tenths, or I'm sorry, not the tenths, but the hundredths. So the nearest hundredths, and what it's going to do is it's going to get our total in a dollar format. And we're also going to do the same thing here by encompassing those in parentheses, using the round function that's built into Python, and then we're going to round it to the nearest hundredths as well by adding a 2 there. And what we're also going to do is we are going to import OS into our program. And then we're going to type in os.system CLS for clearing the console. And we're also going to type in os.system CLS. And we're going to paste this after each time it says time.sleep. And after we get our total, we can go ahead and create another input. Exit input is equal to input. And this time we're going to include a message in ours. Would you like to exit program? And if exit input is equal to y, we are going to break, which is going to break out a while loop and print this statement out. Exit application. Elif exit input is equal to no or in. Then we're going to continue. Or actually, we're going to print this out again, just to get that little countdown effect. And else, I'm going to copy and paste that same code for there. It's pretty neat. We got ourselves a 60-line tax calculator. Now let's go ahead and try this out. Python main.py. Get started, enter our subtotal. Let's do 2025. Enter in tax rate and percent. Let's do 7 again. Is the following information correct? Yes. And now it's cleared, and now it has subtotal and tax rate. And it has a tax and total rounded to the nearest cent. And then, would you like to exit the program? Let's say I want to do it again. And then it did a little countdown, and it gets started. Just type in $50. And let's say our tax rate is insane. Let's say it's 15%. Yes, and wow, that's a lot of tax right there. Let's enter yes, and then it said exit application. Now to make this a tad bit better, what we can do is we can type in os.system CLS right there before that last print statement. And let's add a CLS before it says restarting application in 3. Just so that way we don't get it down in the middle of the console and it just first clears it and then does the countdown. And let's go ahead and add a $sign here, percent here, dollar, and dollar. So that way we get those in the dollar amount. And for our final iteration of this little program we made, we can go ahead and run the code again. Python main.py. Welcome to the tax calculator. To get started, enter your subtotal. 1285. Enter your tax rate in percent. It's going to be 2%. Yes. And look at that. Let's not exit the program. Restarting in 2, 1. Enter your subtotal 40. Enter your tax rate in percent. Let's do 50% because we live in an insane country that taxes us like that. And is the following information correct? Let's say yes. Actually, no. Let's not type yes or no. Let's make a mistake and type in G or something. Well, now it just exited the application, and we basically just simulated a crash. And now our Python code has fully been executed. So, we just made ourselves a pretty nifty little tax calculator using while loops, if and elif statements, else, used continue and break, we used time and OS modules, and we used basic input and output with the print and input functions. And we did a little bit of math using the mathematical operators, and that's about it. So we made ourselves a pretty nifty little tax calculator in... I'll go ahead and just remove these spaces. We did all this in 55 lines of code. Pretty neat. So now if we wanted to, we can go ahead and just export this file and upload it to GitHub. And by export it, I mean we could use something like a PyInstaller, which just turns this little console application to a .exe file where we can just click it and run it that way, which I have a video on how to do if you guys are interested. Or we can just go ahead and port this to GitHub, and anyone with a Python environment can download it and run the script for themselves. But that's pretty neat, and that was all for solution 1. Alrighty guys, in our second solution we are going to be working with money again. But we're also going to be working with a JSON file and storing data in that file to access again and again and again. Specifically, this solution, we are going to be working on a banking application. And it's going to allow us to deposit and withdraw cash from either a checking or savings account in Python. This solution is about twice as long as our previous one. It comes out to be exactly 102 lines, I'm pretty sure. So just a little over twice as long. Or actually, maybe a bit under twice as long, I should say. And it's not very hard. It just deals with a lot of input and output. So be sure to watch carefully on where I place certain statements and such. But yeah, I hope you guys enjoy this solution. And before we get started, we need to go ahead and make a JSON file for our project to use. And I'm just going to call this bank.json. And in here, I'm going to add 3 keys. One for checking, savings, and cash. And we're going to set cash to be $500. And I'm also going to open this JSON file to the side here so that way we can pay attention to it later when we're actually using this application. There are going to be 3 imports today. Imports JSON, imports time, and import OS. JSON for obvious reasons. Time so we can implement a countdown restarting kind of simulation thing with our console, and OS to be able to clear that console later. Now we need to open our JSON file with open bank.json. So we defined bank data to be the loaded content inside this JSON file. Then we defined three variables: checking, savings, and cash amounts to be equal to their relative values inside of here. Now we can go ahead and exit this and make a print statement welcoming you to the banking application. A little bit generic, but I didn't really have an idea of what to name this program. Now we're going to write a while true loop. So far, in this while true loop, I created a print statement asking if they want to deposit cash, withdraw cash, or exit. And I'm using numbers to symbolize each of these options. And we're going to use these numbers to actually choose what we want to do, which is why I've created a main option variable and set it equal to the integer conversion of the input. And notice how I left the message and inputs empty. We can do this if we want our input to be taken at the line under our original message, which is in this print statement. So if you want to just Control X this and paste it inside the input, you can. It'll work the same way, but I just like this a bit better. I've created a set of conditionals checking for each option. This else statement is supposed to be here for whenever the user puts in a number other than 0, 1, and 2. So if they put 3, then we're going to trigger this else block, which we could just say invalid input. And this is where like a little countdown thing where it's going to say restarting in 3, 2, 1, etc. But we're not going to do it exactly how we did it in our last solution. We're going to do it within a function. So up here, we can create a function. We can call it countdown. We're going to take in seconds as an argument. Then we are going to type in while seconds is not equal to 0, os.system, cls, print f string invalid option restarting in seconds. Then we are going to type in time.sleep, and let's actually change that to 1, and then seconds decrement by 1 or minus equal 1. After that, we can go ahead and exit the while loop and type in os.system clear. So down here in this else statement, we can go ahead and type in countdown, pass in 3 for 3 seconds, and then continue right after that. And this continue is going to restart the while loop after the countdown has completed. Now, inside this main option equal to 0 conditional, we're going to write another while true loop for depositing cash. So while true. Then we're going to print how much would you like to deposit. I'm going to create another variable, deposit amount. Keep in mind, I am taking this in as a float input, so that way we could input a decimal amount. So maybe we want to deposit $50.67 for an example. So that's why I'm using float right there. And we're also going to round it. So I'm actually going to remove that. So I'm going to type in round. And we're going to round it to the nearest hundreds. And the reason for that is rounding to the nearest hundreds will give us the nearest cent. So for an example, if I input something like $2.34 and there's like a 2 after the 4, it'll just round down to $2.34. Or if I enter an amount like 3.569, it will round to 3.57. So we're just using this to round to the nearest cent, basically. After that, we need to now check if this deposit amount is greater than the cash amount. And we want to check for this because, obviously, we cannot deposit more than what we have in cash. So if deposit amount is greater than cash amount, and we're going to type in os.system, clear console, and we're going to print, you cannot deposit more than what you have in cash. Time.sleep to os.system CLS for clear, and then continue to restart this nested while loop. Keep in mind that the continue here will only restart this while loop right here. It will not restart this one on the outside because the continue statement is only relative to this while loop. But with that out of the way, we can go ahead and create an else statement here. And this time, we are going to go ahead and add our cash into our savings. So with open bank.json, writing mode as JSON file, bank data, checking, plus equals deposit amount, and then bank data cash minus equals deposit amount. So we're moving the deposit amount from cash into checking. Then we're going to type in json.dump bank data JSON file, and indentation is going to be equal to 4. After that, we're going to exit the with block and type in break. And let's actually change this to an elif. Wait a minute. Oh, I'm sorry. That was my fault. Let's see. All right. I actually made a mistake here. Did I? Okay, yes, I did. So I actually forgot to specify where I wanted to deposit the cash. So what I'm going to do is I'm going to Control X this. And you should too, so that way you'll just cut it and not remove it entirely. So in here, we're not going to ask where do we want to go ahead and deposit our cash at. So print, where do you want to deposit cash? And then we're going to create a another input variable, and we're going to call this account option. And then if account option equals 0, let's actually change that. checking 0 or savings 1. Then we can go ahead and paste that code into here. Now we can go ahead and create an else or an elif statement. And this is for if we want to add it into our savings. And lo and behold, we can actually just copy and paste this code again. But the only thing is, instead of checking, we're going to edit that to be savings. So up here, I have the code for depositing the cash into our checking account. And down here, it is for depositing the cash into our savings account. Now, what I can do is I can write else right here, type in count down, 3 seconds, and then type in continue. And this is just in case we hit anything other than 0 or 1. After that, we are now going to type in os.system CLS and then break. And we're going to type it inside the same scope as this while true loop right here. So that way we'll break out of that loop and we'll start seeing this message again. So that is it for our depositing functionality. Now we need to do the same thing for actually withdrawing our cash. So we are going to do this kind of like the same thing. And we're just going to copy paste those 2 lines right here. Withdraw cash. And if account option is equal to 0. And pass and else and countdown 3 continue. And again, this else is here in case we put anything other than 0 or 1. So now what we can do is we could come back up here and copy and paste this code right here. Actually, let me see. All right, so I made another issue. This needs to be while true. And then we need to indent that. So that way we can put all this in a while true loop. Just like we did up here. And I'm going to go ahead and actually... No, I won't collapse it, because we might need it again. So, if account option equals 0, how much would you like to withdraw? And we're going to change this to withdraw amount. And we want to, essentially, we want to check if the withdrawal amount is greater than... wait, which option was this? Main option 1. Okay, I mean, that's supposed to be 0. Okay. So for 0, if this is greater than checking amount, then you cannot withdraw more than what you have in checking. And if it's not, then we are going to type in minus equal and plus equal here. So that way we're taking out of our checking and putting it into cash. And just to make sure I did that right, and which I did, let's go. Now what we can do is we can go ahead, take this. Yeah, I'll take this right here, paste it here. And then We are going to type in savings amount right there. Change this to savings. And we leave the sign the same. Because we're withdrawing it. We want it to go back in cash. Else continue, or else count down and continue. Oh, and we want this to come over here as well. So that way, whenever we're done withdrawing, it'll go back to this main menu screen. Now for option 2, we want to simply break because we're exiting the program, and then we'll go ahead and print in os.system CLS. Sweet. Let's go ahead and run this code. Pay close attention to the checking here. So I want to deposit cash. Where do I want to deposit? I want to deposit into my savings. How much do I want to deposit? I want to deposit $150.99. And that worked. And for some reason, we exited program. Okay, why? So this break. Okay, so this actually needs to be indented. That's my fault, guys. Or wait, does it? Might actually not have... Oh, wait a minute. Maybe... Yeah, it needs to be continue. Sorry, guys, that's my fault. Alright, well that works at least. Let's try to deposit into our checking instead. So, deposit cash, checking, how much do I want to deposit? Let's do $50.25. That works, and okay, we're getting that again. So, let's say I want to withdraw some cash, and I want to... Okay, let's actually try that one more time. Alright, so we're getting that. Let's see what I did wrong. Okay, that's why. So that was just an issue on my part. Sorry, guys. So I want to withdraw some cash, and I want to withdraw it from my savings. How much do I want to withdraw? I want to do $50.25. And it looks like it added it back to cash, I think. Let's try it one more time. $50.25. Wait a minute, whoops. Savings, $50.25. And it added it back to my cash and took it away from savings. Let's try exit, and it works perfectly. Sweet. So, it looks like this little nifty banking application works. And we can withdraw, we can deposit, and yeah. Now, let's try one more time. And this time I want to try and see how much. Okay, I have $3.99 in cash. I want to deposit cash, and I want to see if the threshold works. The check for seeing if we're trying to deposit more than what we have. 0, and let's do like 1,000. And okay, you cannot deposit more than what you have in cash, and it went ahead and restarted the program. Sweet. So that proves that that works. And yeah, so we have a while loop, and another while loop, and another while loop, and a bunch of if statements, and elifs, and elses, and a bunch of continue and break statements, and a bunch of input and output. So that's all that we really covered. We made a function, we've opened a file, we've opened a JSON file, we've manipulated a JSON file, we've used the time and OS modules as well. And we used a little os.system CLS method. How delightful. And now that we have done this, we can go ahead and move on to the final solution. Alrighty, guys. In our last solution, we are going to be making a simple console-based calculator. This calculator is going to be able to perform addition, subtraction, multiplication, and division, and it's all going to be working with two inputs, x and y. We're going to be doing this under a while loop, and we're going to be using try and except blocks to actually perform the math. So the first thing we're going to do is we're going to type in print, welcome to console calculator. Then, while true, x is equal to float input, enter value for x, and we're going to do the same thing for y. Then we're going to type in try, z is equal to, actually, wait a minute. First, we need to specify which arithmetic we're going to be doing. So, arith option, that's a good variable name, is equal to input, integer input. What do you want to do? Add 0, subtract, which is going to actually be 1, multiply 2, and divide 3. And then, if arith option equals 0, then we're going to add, so try. Answer. And let me just change that to an F string. Now we can go ahead and worry about this try and except block, except value error. And what's going to happen is if we ever enter a letter instead of a number, then we're going to get a value error. And we want to be able to execute some code like maybe print, or whoops, nope, escape. Did not mean to do that. Please enter a valid number for x and y. And then we're going to continue the while loop because we want to start this all over again. And we are actually going to copy and paste this over and over again. And the only difference is we're changing the sign. And that's pretty much it. We can go ahead and run the code. Enter out value for x, do 12, y 8, and let's subtract 8 from 12. So let's do 1, and we get 4. 14, 90, let's multiply, and we get 1260. And I know I didn't really do any of the os.system, CLS type things. I know I didn't really clear the console out, but we can do that later on when we're finding this. So actually, let's go ahead and import OS. And let's go ahead and type in os.system CLS. There we go. And we're going to want to print this on every instance of a value error. And we're going to provide an else block. Invalid option program exited. And I've already done like the whole break and continue thing over and over again. Why not we just leave the while loop and just exit the program if there's an invalid option instead of doing the whole countdown thing we did the two previous solutions. So let's go ahead and run the code again. 12, 3, add 15. Let's do a letter for that, and well, look at that. We still get a value error. And let's go ahead and actually try an accept block up here. Value error, print, and we're going to do the same message again. And technically, we don't need a continue statement up at that point. We have it down here in case this error ever happens again at this point. Typically, actually, it technically shouldn't, but it doesn't hurt to keep it there just in case. But we don't need it up here because it's just going to go ahead and restart the while loop anyways. Or at least I believe it does. If not, we can always add it. And okay, yep. Or invalid option, program exit. Alright, let's go ahead and run the code one more time. 12, 3. Let's divide this time with a 3, and we get 4 as our answer. Let's do 100, 500, and divide that. We get 0.2. Let's do 10, 5, and add them. We get 15. Let's do 500 and 397. And let's subtract them, and then we get 103. Let's do 397 for X, and then 500 for Y this time, and then subtract again, and we get negative 103. So a pretty simple console calculator. And of course, you can go ahead and copy and paste the os.system CLS lines to clear the console anywhere where you want it cleared. But pretty neat. We just made ourselves a very simple console-based calculator. Now, this is it for the course. Congratulations, you made it to the end. I hope that I have taught you something today. I hope that this course may have helped you out on Python programming. If you are a beginner and this has taught you some things, be sure to let me know in the comments. If you have enjoyed this course nonetheless, again, be sure to let me know. And if you want to see courses on other programming languages, or maybe a intermediate or more in-depth course on Python programming, again, be sure to let me know. Otherwise, hit that subscribe button, and I'll see you guys another time. And also, another thing I want to mention before the video ends, these solutions are on my houseofcode.xyz website. The banking and tax calculator solutions will be up. This one will not, because I want to give you guys a little bit of fun and let you guys try to make this on your own. But as always, thank you guys so much for watching. Subscribe, and I will see you all next time. Bye-bye.